3, 2, 1, 0.
In 1977, NASA sent the Voyager spacecraft to explore the outer parts of the solar system and the space beyond. And at one point, the probes ran into something totally nightmarish: a blazing wall of fire measuring temperatures from 54,000 to 90,000 degrees Fahrenheit. Well, did the probes manage to survive these intense conditions? We'll find out soon. Meanwhile, there are several ways to think about where the solar system ends. One way is to say it ends where the planets stop. Another way is connected to the Oort cloud. That's a giant group of icy objects far beyond the planets, the farthest region of the solar system. It is extremely distant, maybe a quarter to halfway to the nearest star. To understand such huge distances, scientists often use something called the astronomical unit, or AU. 1 AU is the distance between Earth and the Sun. For comparison, Pluto orbits between about 30 to 50 AU from the Sun. The inner edge of the Oort cloud is thought to be much farther away, and the outer edge could be even further away. These distances are very hard to imagine. My little brain sputters when considering such. Now, we can also measure them in time instead of miles. NASA's Voyager 1 spacecraft makes almost 1 million miles per day. At that speed, it would take about 300 years to reach the Oort cloud and maybe 30,000 years to reach its outer edge. Now, one more way to define the edge of the solar system is by the Sun's gravity. It might be the area where the Sun can still pull objects back toward it. And finally, we can define it by considering the heliopause, the boundary where the Sun's influence ends. You see, the Sun constantly sends out charged particles in a flow called the solar wind. This wind moves past all the planets and reaches about 3 times the distance to Pluto. The solar wind creates a giant bubble around the Sun and planets called the heliosphere. The heliopause is the outer edge of this bubble, where the solar wind meets the wind coming from other stars, called the interstellar wind. Here, the pressures from the solar wind and the interstellar wind balance each other. This causes the solar wind to turn back and flow along the tail of the heliosphere. As the heliosphere moves through space, it creates a bow shock, similar to the wave that forms in front of a ship moving through the water. So, depending on how you define it, by planets, by the Oort cloud, by gravity, or by the Sun's magnetic influence, the edge of the solar system can mean very different distances. But if we talk about the Voyagers, they came across something intense. It was something we could probably call a wall of fire, blazing heat and intense temperatures. The two probes became the first spacecraft to travel beyond the heliosphere and cross the heliopause. Before the Voyager spacecraft reached the heliopause, scientists did not know exactly where this boundary would be. But the fact that the two spacecraft crossed it at different distances helped confirm some predictions about the heliopause. Scientists did expect that the edge of the heliosphere could move as the Sun's activity changes, a bit like a lung expanding and contracting as we breathe. And the fact that Voyager 1 and Voyager 2 encountered the heliopause at different distances matched this expectation. The heliopause is not a hard edge or solid wall, but the nickname Wall of Fire actually matches the nature of that insane region. Both spacecraft measured extremely high temperatures there, around 30,000 to 50,000 Kelvin, or 54,000 to 90,000 degrees Fahrenheit. Despite these extreme temperatures, the spacecraft were safe. The particles in this region are very far apart, so collisions are rare and not enough heat could reach the spacecraft to harm them. Nearly 50 years after their launch, Voyagers 1 and 2 continued to send back data from beyond the heliopause. They are the only two spacecraft that have crossed this boundary so far. Together, they have already made several curious discoveries about space outside the solar system. For example, Voyager 2's magnetic field measurements confirmed a surprising result from Voyager 1. Just beyond the heliopause, the magnetic field lines are aligned with the magnetic field inside the heliosphere. Before Voyager 2, scientists only had one measurement from Voyager 1, so they could not be sure whether this alignment was real or just a coincidence. Voyager 2 confirmed that the alignment was real. The magnetic fields inside and just outside the heliopause apparently run in parallel. These discoveries give scientists important information about the structure and behavior of space beyond the solar system. Now, let's dig a little deeper into the Voyager program itself. It's made up of 2 spacecraft, Voyager 1 and, wait for it, Voyager 2. Even though Voyager 2 was launched first in August 1977, Voyager 1 took off just 2 weeks later on a faster, more direct path. These 2 spacecraft have been traveling for more than 40 years, exploring worlds no human will ever walk on, at least in the near future. The 2 Voyager spacecraft are nearly identical. Each has a large radio dish that is 12 feet across. This dish sends data back to Earth. They also have 16 thrusters to control their direction and make sure the dishes always point toward our planet. The thrusters use special hydrazine fuel, and the spacecraft's electronics are powered by thermoelectric generators that run on plutonium. Each Voyager carries 11 scientific instruments. About half of them were made specifically to study planets, and most of those are now turned off. The turned-off instruments include several cameras, spectrometers, and 2 radio-based experiments. During their long journeys through the solar system, the Voyagers took tens of thousands of images and measurements. This data has changed what we know about the outer planets. When the Voyagers reached Jupiter, they gave us our first detailed look at the planet's atmosphere. They showed that the Great Red Spot was a huge storm spinning counterclockwise and interacting with smaller storms nearby. The Voyagers also discovered a faint dusty ring around Jupiter. They studied Jupiter's moons, too. They found volcanoes on Io, saw linear features on Europa that hinted at a hidden ocean beneath its icy surface, and confirmed that Ganymede is the largest moon in the solar system, larger even than Saturn's moon Titan. Next, the spacecraft flew past Saturn. They measured the planet's atmosphere and studied its famous rings, discovering gaps and waves we still see today. Voyager 1 looked through Titan's thick haze and suggested that the moon might have liquid hydrocarbons on its surface. It was later confirmed by other missions. Voyager 1 also found 3 new moons orbiting Saturn: Atlas, Prometheus, and Pandora. So that's where she ended up. After Saturn, Voyager 1 continued out of the solar system, while Voyager 2 headed toward Uranus. Voyager 2 discovered 11 new moons and 2 new rings there. It also observed strange features, such as Uranus's unusual magnetic field and a surprisingly small temperature difference between its equators and poles. Voyager 2's final planetary stop was Neptune. It happened 12 years after leaving Earth. There, it discovered 6 small moons and rings around the planet. It studied Neptune's atmosphere and magnetic field, and observed volcanic vents on Triton, Neptune's largest moon. After this, Voyager 2 joined Voyager 1 on its journey toward interstellar space. Voyager 1 entered interstellar space in August 2012, and Voyager 2 joined it in November 2018. These missions helped scientists measure the edge of our solar system, about 11 billion miles from the Sun. The spacecraft still sends back data about this mysterious region. By the way, after its planetary visits, Voyager 1 took the famous pale blue dot photo of Earth from about 3.7 billion miles away. Today, Voyager 1 is about 15.8 billion miles from Earth, and Voyager 2 is about 13.1 billion miles away. Each Voyager carries a golden record, a time capsule from Earth for other civilizations it might meet. The record covers include instructions for playing it, a map showing Earth's location, and a drawing of a hydrogen atom. The records are cleverly plated with uranium, so the decay of the uranium could help discoverers figure out when the record was made. The records contain 115 images showing Earth, humans, animals, plants, and our solar system. They include natural sounds like waves and birdsong, greetings in 55 languages, brainwave recordings, and a mix of music, ranging from Beethoven to Chuck Berry and folk songs. For 50 years, astronomers searched for something invisible at the center of our galaxy. It's almost impossible to detect. yet powerful enough to reshape the Milky Way. Now, they may have finally found it, and it's not a new star or a planet. It's a wind coming from the supermassive black hole Sagittarius A star, and it might be carving a giant cavity in space. So, black holes just don't pull things in. Sometimes they blow things away too. When gas and dust fall toward a black hole, they don't drop straight in. They start spinning around it at crazy speeds, like water circling a drain. All that motion creates a huge amount of heat, and the hotter it gets, the more energy gets blasted back into space. When you throw wood into a campfire, the fire doesn't just burn the wood. It also throws out heat, smoke, and sparks. A feeding black hole does something similar. When it gobbles up material, it produces immensely powerful streams of gas that dash outward, basically a kind of cosmic wind. Astronomers see these winds around supermassive black holes all over the universe. Then, what about the black hole at the center of our own galaxy? Sagittarius A star is a supermassive black hole with a mass about 4 million times larger than the Sun. At the same time, it's surprisingly compact. If you placed it in our solar system, it would easily fit inside the orbit of Mercury. In 2022, scientists finally captured the first image of it. Not the black hole itself, it's impossible to see because no light can escape it. But they managed to photograph the glowing ring of superheated gas swirling around the hole at incredible speeds. This makes the black hole look like a giant burning donut floating in space. In any case, if black holes produce winds, ours is massive enough to create some too, even though it's barely eating anything right now. And still, for more than 50 years, nobody could find this wind. Even when bigger telescopes and better instruments came, the wind was still missing. The problem is that we were trying to look through our own galaxy, where huge clouds of gas and dust sit in the way and block most of the view. It's a bit like trying to spot a flashlight through a thick fog. But now that long search may finally be over. A team of researchers from Northwestern University claims they've finally found it. If it's so, we might be able to see what that supermassive monster at the center of our galaxy is actually doing. Finding that wind wasn't easy. For one thing, astronomers had to look straight through the thickest part of our galaxy, with all kinds of glowing clouds and other stuff floating around in the way. And we couldn't rule out the possibility that Sagittarius A star wasn't producing any detectable wind at all. But this idea didn't seem believable. A black hole doesn't need to be actively swallowing stars to create a wind. As long as some material is falling toward it, there should be at least a small outflow. Now, the universe doesn't really do perfect emptiness. Even the emptiest regions still contain a few particles here and there. And Sagittarius A star exists inside a galaxy full of gas and dust. So it should be blowing something outward. The challenge was finding it. Until researchers finally spotted a clue. It wasn't the wind itself yet. They found the mark it left behind. Near our black hole, they discovered a huge gap in the surrounding gas. Something seemed to have pushed that gas away, and the most likely culprit was the black hole. Astronomers already knew there was a lot of gas near the center of the Milky Way. Most of it sits in a giant ring around the black hole. It's like a huge cosmic traffic circle made of gas. But for years, scientists believed that the area closer to the black hole was mostly empty of cold gas because they only saw hotter gas there. Then, our astronomers used ALMA, one of the most powerful radio telescope systems on Earth, and they found something unexpected. There was much more cold gas near the black hole than anyone thought. To track it down, they followed carbon monoxide gas. That might sound strange, but researchers use carbon monoxide the same way detectives use footprints. It's one of the easiest ways to see where cold gas is hiding in space. Once they started mapping this gas, the astronomers noticed something odd. A huge chunk of it was missing. Right next to the black hole, they found a giant cone-shaped gap stretching more than 3 light-years into space. That's almost 20 trillion miles, nearly 200,000 times more than the distance between the Earth and the Sun. And the researchers think it was the black hole's wind that gradually blasted that gas out of the way. But the team still needed proof, so they started checking other possibilities. Maybe a nearby star had blown the gas away. Well, that didn't work. The empty region was simply too large. Even if you combine the winds from all the stars near the center of the galaxy, they still wouldn't have enough energy to create such a giant gap. Well, maybe it was a massive stellar explosion. Nope, the shape didn't match. The gap wasn't random. It formed a huge cone, and that cone pointed straight back towards Sagittarius A star. That's when the team found another clue. NASA's Chandra X-ray Observatory had already been studying the same region. And when the researchers compared the data, they noticed that the cone-shaped gap lined up with a source of X-rays. That was exactly what they wanted to see, because hot gas from the black hole would produce X-rays as it moved through space. The pieces started fitting together. The giant cone, the missing cold gas, the X-rays, and the direction of the structure. Every clue pointed to Sagittarius A star and the wind it produces. But don't imagine a giant blast, a cosmic hurricane, shooting across the galaxy. This wind is actually pretty weak compared to the powerful jets some black holes produce. The researchers also think that the wind doesn't always blow in the same direction. Over time, it shifts and pushes gas around different areas near the black hole. That's why the cone-shaped cavity isn't perfectly symmetrical. And still, even though the black hole wind itself isn't particularly dramatic, the fact that it exists means that our cosmic neighborhood isn't some special windless exception. The supermassive black hole sitting at the center of the Milky Way apparently follows the same rules as everyone else. This discovery won't change our lives, at least not directly. After all, the wind is happening about 27,000 light-years away, near the center of the Milky Way. Nothing from it is going to reach Earth. But it's important because it can help us figure out how black holes affect the galaxies around them, and why some galaxies keep making new stars while others stop. We might even find out how galaxies change over billions of years. You see, scientists think black holes are one of the main things shaping galaxies. But to make sure it's true, we need to understand how black holes interact with the gas around them. And the newly discovered wind might be part of that puzzle. Most supermassive black holes in the universe spend most of their lives in a quiet state, just like Sagittarius A star. The problem is that those black holes are usually millions or even billions of light-years away. They're simply too far away to study in detail. Astronomers usually notice distant black holes only when they're extremely active, when they're swallowing huge amounts of material. That's like trying to understand how people normally live by only watching them during carnivals. Sagittarius A star gives us something we've never had before, a close-up look at what a supermassive black hole does during its ordinary quiet life. And if our black hole behaves this way, there's a good chance that countless other quiet black holes across the universe do exactly the same thing. So our galaxy is constantly moving through space at incredible speed, together with thousands of other galaxies. Weirdly, all of them are drifting in the same direction, pulled by something unbelievably massive that we still can't see directly. We've known about this space mystery for decades, but now astronomers think there may be one more force at play. Now, for a long time, scientists have known the Milky Way isn't standing still. Instead, it's traveling at about 375 miles per second. If you were moving at the same speed, you'd go from New York to Los Angeles in about 10 seconds. And apparently, our home galaxy has a destination in mind. No one can see it directly, but we can observe its effects. We also gave it a name, the Great Attractor. Hey, that was my nickname in high school. No, not really. This enigmatic region is in a part of the sky called the Zone of Avoidance. It's hidden behind the thick disk of the Milky Way. Unfortunately, too many stars, dust, and gas are in the way too, so we just can't look through this thick cloud. It's like trying to see through heavy fog, but this fog is made of stars. So instead of seeing the Great Attractor, scientists had to figure it out from our motion. Back in the 1980s, a group of astronomers nicknamed the Seven Samurai were tracking about 400 galaxies. And they noticed something odd. A lot of those galaxies were all drifting in the same direction. It was like something massive was pulling them in. That something ended up being the Great Attractor, located around 150 to 250 million light-years away. How did we figure it out? Well, at first, astronomers thought we were just moving toward the Virgo cluster, a big group of galaxies nearby. But then they realized that the Virgo cluster was moving too, toward an even larger structure called the Virgo supercluster. And then, in 2014, it turned out that all of that was part of an even bigger structure called the Laniakea. That's a giant region containing around 100,000 galaxies, including the Milky Way. And somewhere near its center is what we now call the Great Attractor, a massive gravitational anomaly, pulling huge numbers of galaxies in the same direction. But even the Great Attractor is not the final boss in this story. When we zoom out even more, things get even bigger. The galaxies near us, and the Great Attractor itself, are all moving towards something even larger, called the Shapley supercluster. It contains more than 8,000 galaxies and has a mass of over 10 million billion suns. It's the most massive galaxy cluster within about 1 billion light-years of us, and everything in our corner of the universe, including our own galaxy, is slowly drifting toward it. But let's get back to the Great Attractor. Is it actually dangerous for us? Are we going to end up falling into it? Definitely not. Even though it sounds like we're being pulled in, the Milky Way will most likely never actually arrive there. The reason is that the Laniakea supercluster isn't a tightly bound structure. Now, space is expanding all the time, and that expansion keeps stretching distances between galaxy groups. So, while gravity is pulling things together locally, the universe is also pushing everything farther apart on the biggest scales. Right now, gravity is still strong enough that the Milky Way and nearby galaxies are drifting toward that region. But over billions of years, the expansion of space will slowly win. At some point, the pull from the Great Attractor will get too weak compared to how fast space is stretching. The motion won't stop completely, but we won't be able to reach our destination. So instead of a dramatic final collision, we'll just keep moving in that direction for a long time, and we'll never actually arrive. Good news? Well, it would be if scientists hadn't found something that might influence our galaxy even more than the Great Attractor. It happened like this. At one point, astronomers needed a proper map of where galaxies were. For a long time, there was a gap in that map. It looked like something massive was sitting behind the Milky Way, but no one could actually see it. Galaxies nearby were moving in slightly strange ways, like they were being tugged by something big. But the object causing those strange patterns was hidden from our sight. Optical telescopes just couldn't see it. Until scientists used the Meerkat radio telescope in South Africa, which doesn't rely on visible light. Instead, it picks up radio waves, especially something called the 21-centimeter hydrogen line. That signal comes from neutral hydrogen gas and passes through dust almost totally unaffected. And suddenly, the hidden part of the universe became much more accessible. Astronomers were especially interested in the Vela supercluster. It's massive, stretching roughly 300 million light-years across and located around 800 million light-years away. We'll get back to the space monster a bit later. First, let's figure out how Meerkat can actually see galaxies sitting behind the Milky Way's disk. You see, each galaxy leaves a clear signature in that hydrogen signal we talked about. If a galaxy is moving away from us, its signal gets stretched out. In other words, it shifts toward lower frequencies. That's called redshift. And because the universe is expanding, that redshift can also tell us the distance. So by measuring it, scientists can figure out where each galaxy sits in 3D space. This helped astronomers detect thousands of previously unseen galaxies. The previous vague, blurry region of space suddenly turned into something very structured. Scientists saw a huge cosmic formation with two dense cores. It means that the Vela supercluster is a real complex structure, and we can finally see its shape. There's another interesting thing. That hydrogen signal doesn't just trace where galaxies are. It also shows us regions of cold, dense gas, the raw material galaxies use to form new stars. So this map also hints at where future star formation is more likely to happen, giving us a rough preview of how the universe might evolve. Now that we've mapped Vela, its size is hard to ignore. That's about 30 million billion solar masses of material. This supercluster is among the most massive structures we know of in the nearby universe. And such big structures act like gravity wells. Galaxies slide toward those regions, forming large flows across huge distances. This affects us directly. We already know that the local group, the Milky Way, Andromeda, and a bunch of smaller galaxies, is moving through space at a breakneck speed compared to the cosmic microwave background. This microwave background is the leftover glow from the Big Bang, which fills the whole universe. Scientists can already explain a lot of that movement using known structures, like the Great Attractor. But not everything adds up. And that's where Vela comes in. Its size and location affect how our galaxy moves. So, some of the missing motion we saw starts to make sense when we add Vela in. It can help clear up a gap in our models of how the universe moves. At the same time, Vela shows that our map of the universe is still incomplete. For a long time, astronomers treated the zone of avoidance like a blank region. Not super important, just hard to look through. But now, it turns out that hidden regions can have structures just as large as the ones we already know about. So, a pretty obvious question is, if something this big stayed hidden for so long, what else is still out there? We might find out pretty soon. Meerkat is already one of the most sensitive radio telescopes we have for the southern sky. And the next step is the Square Kilometer Array. This one will be able to pick up fainter galaxies and trace the thin cosmic filaments that connect everything to a ginormous cosmic web. Right now, Meerkat has basically revealed the core of Vela. SCA could show how it spreads outward, forming part of a much larger cosmic network.
It's dark and incredibly cold. There's no oxygen. There's no water. There's no life. But the James Webb Space Telescope doesn't seem bothered by all this. Its main goal is to find the very first galaxies that formed billions of years ago in the early universe and observe the stars making up distant planetary systems. Its mission is to... But wait, what is that? The James Webb Space Telescope has discovered something absolutely amazing. A star-planet hybrid with very strange clouds. This bizarre world called VHS 1256b is actually a brown dwarf. Those are bigger than planets, but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium, like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us it appears to be dark orange or magenta. The brown dwarf we're talking about is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars. And to complete one orbit, the brown dwarf needs 17,000 years. In fact, astronomers found out about this unusual exoplanet in 2016. But at that time, they didn't classify it as a brown dwarf, and thus couldn't explain its puzzling reddish glow. Now, thanks to the James Webb Telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor, but those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Scientists have been putting forward theories about the existence of such sand clouds on exoplanets for quite some time. But the discovery the James Webb Space Telescope made is the first real proof. The silicate particles on the sandy dwarf are most likely quartz or some other mineral. In size, they're less than a micron, and 1 micron is 1/25th of a thousandth of an inch. In other words, they look like particles in smog. The exoplanet seems to have an atmosphere which contains some water, methane, and other substances and minerals. Interestingly, this atmosphere isn't still. It's constantly undergoing extreme changes. Another cool thing about it, scientists have detected carbon dioxide. And this is only the second confirmed discovery of this gas on a planet outside the solar system. By the way, the James Webb Space Telescope, with the help of which astronomers discovered our sandy brown dwarf, is an absolutely stunning piece of equipment. Around 100 times more powerful than Hubble. Even though the telescope itself is 3 stories high and its size equals that of a tennis court, its mirrors are the lightest large telescope mirrors of all time. When all the 18 mirrors of the telescope were completed during the manufacturing process, their mass was reduced by 92% in comparison to the initial discs. Each mirror weighed a mere 44 pounds. The telescope's mirrors seem to be gold, but in reality, they're made of beryllium, steel gray, lightweight, and brittle metal. There is indeed a gold coating on each mirror, but they can't be produced entirely out of gold, since this material tends to expand and contract even with small temperature changes. That's why the total amount of gold in the James Webb Space Telescope is less than 2 ounces. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than -370 degrees Fahrenheit. That's cool enough to make liquid nitrogen. A truly enormous 5-layered sun shield stretches around the telescope and reflects away as much sunlight as possible, letting the telescope stay cool. The telescope was launched near the equator because Earth spins a bit faster there, and this gave the rocket some extra push. The telescope orbits the Sun more than 1 million miles away from Earth, and when it runs out of fuel, it'll keep orbiting the Sun indefinitely. On the other hand, even though the telescope wasn't actually designed to be serviced or upgraded, it might potentially be refueled with the help of robots. This would extend its life. Anyway, if you think that our newly founded brown dwarf is the only bizarre exoplanet out there, let me show you some other breathtaking worlds. There is an exoplanet that is really something else. Just look at its awesome magenta color. You can find it in the Virgo constellation. The planet is called Gliese 504b. It orbits very far from its parent star, 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. One of the oldest exoplanets we know about is about 12.7 billion years old. It's almost 3 times as old as Earth. This also means that the so-called Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its 2 parent stars have had enough time to evolve into a white star and a pulsar, making almost 100 revolutions per second. I bet sunrises on this planet must look awesome. Just 20 light years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming the Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's. The exoplanet also produces amazing auroras. That's why when it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf. But later, scientists got some proof that this space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet in the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create mesmerizing light shows. The next exoplanet isn't like any other. It's often called Super Saturn or Saturn on steroids. That's because J1407b has a colossal system of rings. They're 640 times as large as those our Saturn has. This bizarre world is the only planet we know about that has rings similar to Saturn's. If you moved this giant to our solar system and used it to replace Saturn, its rings would look many times larger than a full moon. An exoplanet called WASP-12b munches on the light coming from its star. It's one of the darkest worlds people know about. All because its day side consumes light rather than reflects it back into space. The egg-shaped planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. It might be the main reason for the temperatures on the surface of the planet that can rise up to 4,600 degrees Fahrenheit. The night side of the planet isn't as hot as its day side, a mere 2,200 degrees Fahrenheit. The difference in temperature makes water vapor and clouds gather above the surface of the planet. And from time to time, swirls of material from the planet's superheated atmosphere spills onto its star. What a view! Discovered in 2017, KELT 9b is one of the hottest exoplanets we know of. The temperatures there can reach 7,800 degrees Fahrenheit. For comparison, the temperatures at the surface of the Sun reach 10,000 degrees Fahrenheit. The planet is probably so insanely hot because it orbits extremely close to its star, KELT 9, which is way hotter and bigger than our Sun. Experts believe that the giant star might one day evaporate the entire planet.
Astronomers found a black hole that seems way too big for its age. By everything we know about space, it shouldn't have had enough time to grow, and the more scientists studied it, the weirder it got. You see, the first black hole we managed to photograph was at the center of the galaxy Messier 87. That space behemoth contains about 6 billion times the mass of our Sun. And now, meet TON 618. It contains about 66 billion suns worth of mass. Astronomers call such monsters ultramassive black holes. The scale of this black hole is difficult to picture. Even if you took all the stars in the Milky Way galaxy and packed them into a single black hole, it would still not be enough. But there's a problem. Nobody really knows how big a black hole can actually get. For a long time, astronomers believed that there had to be some limit. After all, growing a black hole isn't easy, let me tell you. To keep feeding, it needs gas. This gas falls toward a black hole and heats up to incredible temperatures. This makes it start blasting out radiation, which pushes back on the rest of the gas trying to fall in. This makes it harder for the black hole to grow. So scientists call this phenomenon the Eddington limit, basically the universe's way of putting the brakes on a starving black hole. But this limit doesn't actually determine how big a black hole can eventually get. And as far as we know, there may be no maximum size at all. So in theory, you could keep merging black holes together over and over again, making them larger each time. It's like rolling a snowball that keeps picking up more snow. Most of the time, though, black holes grow through a process called accretion, which is just a fancy word for feeding. Plus, black holes don't usually swallow matter the way most people imagine. Gas doesn't simply fall straight into the hole. Instead, it forms a huge spinning disk around it. Inside that disk, particles are constantly crashing into one another, like in a giant cosmic bumper car arena. During every collision, some particles gain energy and get pushed farther away from the black hole. Others, less lucky, lose energy and slowly drift inward. After countless impacts, some particles lose so much energy that they can no longer resist the black hole's gravity. They spiral closer and closer until they reach a region called the innermost stable orbit. You can think of it as the last safe lane before the final drop. Outside this boundary, matter can still orbit. Inside it, there's no stable path left. Once something crosses that line, it's basically on a one-way trip toward the event horizon, also known as the point of no return. Now, despite how dramatic this process sounds, all of this happens very slowly. It takes millions of years for a black hole to gain a modest amount of mass. And that's exactly why TON 618 is such a headache for astronomers. Somehow, despite all these limits and bottlenecks, it managed to grow into a monster containing about 66 billion suns worth of mass. Now, remember that other problem black holes have? Yep, they can't eat as much matter as they want. When huge amounts of gas pile up around a black hole, they form a fast-spinning disk. Inside that disk, particles are moving at incredible speeds and constantly crashing into each other. All those collisions create friction, and friction creates tons of heat. In fact, the disk gets so hot that it starts glowing. It can actually shine brighter than an entire galaxy. And that's how astronomers find many supermassive black holes. From billions of light-years away, they often look like tiny points of light that completely outshine the galaxies around them. Those objects are called quasars. For a long time, scientists didn't even know what quasars were. They looked like stars, but something was off. Much later, astronomers realized those were supermassive black holes feeding at the center of galaxies. But the light helping us find black holes also creates a problem for them. The disk can become so bright that its light starts pushing outward, and because light carries energy, it can actually push on things. So the brighter the disk becomes, the stronger that pressure gets. Eventually, it starts pushing gas away from the black hole, instead of letting it fall in. It's like trying to pour more water into a funnel while a powerful fan is blowing upward from the bottom. In other words, if too much gas builds up, the black hole's feeding disk becomes brighter. The brighter it gets, the more material it pushes away. Once a balance is reached, the black hole can't eat any faster, and no matter how much extra gas you throw at the black hole, it can only grow at its own pace. The rest gets blown back into space. So, the question remains, how did this ultramassive black hole manage to find and swallow so much material to grow to such gargantuan proportions in a relatively short time? And TON 618 may not even be unique. Astronomers have found another black hole that seems to break the same rules. Recently, the James Webb Space Telescope spotted an object called QSO-1 around 13 billion light-years away. That means we see it as it looked when the universe was only about 700 million years old. At the center of QSO-1 sits a black hole with a mass roughly 50 million times greater than the Sun. But the black hole itself isn't the biggest surprise. It's the galaxy around it. Astronomers thought they had a pretty good idea of how supermassive black holes form. Usually, it goes like this. A galaxy forms first, then stars begin to appear. Much later, some of those stars collapse into black holes. And over millions or billions of years, those black holes grow by feeding on gas, dust, stars, and sometimes even other black holes. Eventually, a large galaxy ends up with a large black hole at its center. The two are supposed to grow together. Well, QSO-1 doesn't seem to know that. The galaxy looks relatively small and undeveloped, while the black hole already appears unusually massive. It's like finding a finished skyscraper standing in the middle of a town that's still being built. Even in today's universe, where we see some truly enormous black holes, they usually don't dominate their host galaxies to this extent. This discovery is especially important because astronomers have managed to measure the black hole directly. In the past, we could only estimate a black hole's mass in the early universe, relying on indirect methods or assumptions based on nearby galaxies. Scientists weren't sure whether those assumptions still worked when the universe was young. Well, QSO-1 gave us a chance to check this. Using James Webb's NIRSpec instrument, researchers measured how fast gas was moving around the black hole. The stronger the black hole's gravity, the faster that gas should move. That's how they got the mass of about 50 million suns. The James Webb Telescope keeps finding similar examples. Astronomers call them little red dots, small distant objects that seem to contain surprisingly massive black holes. James Webb has already found hundreds of them. The deeper scientists look into the early universe, the more often those objects show up, and according to many current models, some of them simply shouldn't have had enough time to grow that large. So, how do they do it? Well, nobody knows for sure. One idea is that some giant black holes form directly from enormous clouds of gas, skipping several stages of the normal process. Some scientists think dark matter might have somehow helped these black holes bulk up way faster than they should have. But honestly, nobody knows yet. But what if galaxies don't always create supermassive black holes? What if, at least in some cases, supermassive black holes appeared first? If that's true, then some of the earliest galaxies may not have built their central black holes at all. Instead, those black holes may have helped build the galaxies around them.
You're traveling through deep space, circling stars and entire galaxies. Whoa, looks like this multicolored nebula will soon collapse under its own weight and explode like a supernova. Now let's carefully circle this black hole. Try not to get caught in its gravitational field, or it'll swallow you like a space monster. Wait, what's that strange structure right there? It's a glowing wall, and if you look closely, each glowing dot is an entire galaxy. That wall has about 100,000 of these galaxies. The Milky Way has 100 billion stars, so this wall holds a quadrillion, that's 10 followed by 15 zeros, of stars like our sun. This giant structure is called the South Pole Wall. It's located about 500 million light-years from Earth. By comparison, the closest star to our home is Proxima Centauri, and it's about 4.2 light-years away. Rockets can cover that distance in about 73,000 years. So the journey to the South Pole Wall may take longer than our solar system exists. And this wall is simply gigantic, even on a cosmic scale. It's about 1.37 billion light-years long. To give you an idea of how large that is, the Milky Way is only 100,000 light-years wide. But you can't see this wall even with the most powerful telescope. The problem is that the Milky Way itself obstructs your view. It's so bright that it's hiding this wall. It's like trying to look at the starry sky in a metropolis. The light pollution won't let you do that. Scientists have been able to detect this galactic wall by measuring redshift. We know that all objects in the universe are moving. They spread out from each other as a result of the Big Bang, which happened billions of years ago. And when galaxies move, their light waves change slightly. By measuring this change, we can understand what the object is and how it moves. And this wall isn't even the largest in our universe. This is the Hercules Corona Borealis Great Wall. It's a giant flat superstructure about 10 billion light-years wide. That's around 10% of the entire observable universe. And it's also a wall. That is, a cluster of galaxies. We were able to detect this giant structure by gamma-ray bursts. It's the brightest electromagnetic event in the universe. You could even see it in the far reaches of our universe. Such bursts are a very rare event. In the Milky Way, for example, it happens once every few million years. If we notice many such bursts in a short time from the same place, it means that there are many objects like the Milky Way in that place. So, there are a lot of galaxies out there. Another unusual giant structure in the universe is the huge, large quasar group. It's about 4 billion light-years across. So it takes a photon of light almost as long as our planet has existed just to get from one side of the structure to the other. And if you put the huge, large quasar group on the scale, it would be 6.1 billion times heavier than our Sun. Scientists have found that there are at least 73 quasars in that structure. These are some of the most unusual objects in the universe. They are the active cores of galaxies. At the center of a quasar is a supermassive black hole. This giant eats up the matter around it. A wild force of gravity twists the matter around the black hole, forming a disk. And this disk is the source of the strongest radiation out there. By comparison, the radiation from a single quasar is tens or hundreds of times stronger than that of all the stars in our galaxy put together. Because of such strong radiation, we can detect quasars, even at very long distances. That's why they're also called beacons of the universe. Scientists use quasars to study the universe and the movement within it. One of the most distant quasars from us is about 13.1 billion light-years away. This makes it one of the oldest objects in the universe. It appeared about 690 million years after the Big Bang, and it's almost 3 times older than our solar system. It's still glowing with extreme brightness, about 4 and 14 zeros times brighter than the Sun. Scientists explain that at the center of the giant is a supermassive black hole, 800 million times heavier than the Sun. All these giant structures are just building blocks of our universe. Look, this is our solar system. Now, zoom out a little, and this is where our home star is in the Milky Way galaxy. Zoom out again. Here's a local group of galaxies. All the bright spots here are galaxies. Here's Andromeda, and here's the Triangulum galaxy, plus a few dozen other slightly smaller galaxies. They're all gravitationally connected. The size of this structure is about 10 million light-years. That's 100 times the width of our galaxy. Zoom out, please. This one is the Virgo supercluster. It's 20 times larger than the local group. There are about 30,000 different galaxies, and the mass of the whole thing is about 1 in 15 zeros solar masses. Zoom out again. Laniakea. This structure is almost 3 times larger. It includes the Virgo supercluster and other smaller clusters. And there are about 100,000 galaxies here. It's not over yet. Zoom out one more time. Here's the Pisces-Cetus supercluster complex. This giant galactic structure contains about 60 clusters of galaxies. So there are more galaxies in it than grains of sand in the desert. You know what to do. Zoom out! Phew, this is the observable universe. there are over 500 billion galaxies. And the stars? Well, there are about 1 billion trillion stars. The observable universe has its own structure. Clusters of galaxies form chains and walls, as you've seen before. But these strands are separated by huge regions of absolute emptiness. These areas are called voids. In these places, there is no matter at all. There are fewer molecules in the voids than in an empty room. One of these voids has a very mystical reputation. It's the Eridanus supervoid, or the cold spot. It appeared here only 380,000 years after the Big Bang. It's almost 1 billion light-years wide and could hold hundreds or thousands of galaxies with trillions of stars. Some scientists believe that this cold spot may have been the result of the largest collision ever, a collision of universes. There's a theory that our universe is some kind of bubble, a huge sphere that contains all these walls and chains of galaxies. Now imagine that there's an infinite number of these bubbles. They could be parallel worlds or different universes. Many years ago, one bubble came close to the bubble of our universe. Their walls touched, and the two universes connected for a while. It's like two drops of water coming together. But that universe kept moving. The area where the bubbles joined became thinner and thinner until that connection broke, and the two bubbles detached from each other. At this point, the second universe ripped some of the material out of our bubble. All those galaxies that used to fill the Eridanus supervoid ended up in a parallel universe. Scientists supposed we might travel through other bubbles. Flying to the supposed wall of our universe would take forever, and then it would take even longer to fly through interuniversal space. So we have to use portals, or wormholes. Here's how it works. Imagine a piece of paper with point A on one side and point B on the other. Instead of moving all the way across the sheet of paper, we just fold the sheet so that point A is right above point B. All that's left to do is make a small hole, and the journey takes only moments. Some scientists believe that such shortcuts through universes lie inside black holes. But how do you survive falling into a black hole? You just have to pick one that's big enough. It's all about gravity. Imagine you're falling into a black hole right now. The closer you get to it, the stronger effect it has on you. It intensifies with every inch. At one point, the gravitational force that affects your head is much stronger than the one that affects your feet. Then you turn into spaghetti. Yum. But if you choose a supermassive black hole, like the ones at the centers of galaxies, the gravitational force in them increases gradually. They can be millions of times heavier than the sun and much bigger. But the gravitational force on your head and your feet will be almost equal, and you will still feel comfortable. Who knows? Maybe if you manage to survive a fall into such a massive black hole, you'd find yourself in a completely different universe where different laws of physics apply. But so far, this is just a theory.
Mission status critical. The spaceship has hit a wall of fire somewhere past Pluto, where you'd expect to see nothing but total silence and icy darkness. The temperatures here reach 30,000 to 50,000 K. That's hotter than most stars. Yet there is no oxygen or actual flames. Is this the edge of our cosmic home brewing heat? Let's dive right in to find out. The Voyager probes launched in 1977 to explore all the planets. But their journey didn't end there. They kept going and became the first human-made objects to leave the solar system. Voyager 1 passed the heliopause in August 2012, and Voyager 2 followed in November 2018. The heliopause is like a cosmic finish line. It's where the sun's solar wind, charged particles streaming out, finally loses its fight against all the interstellar stuff. When Voyager crossed that line, instead of cold emptiness, scientists found scorching hot plasma. Like I said, there's no flame, just superfast particles crashing into each other in ultra-thin plasma. They generate crazy temperatures with almost no heat transfer. Voyager 1's plasma detector failed back in the 1980s, but two other instruments recorded a sharp drop in solar particles and a surge in cosmic rays. Plus, there was a big distortion in the magnetic field. By the way, scientists expected the magnetic field direction outside the heliosphere to flip, but there was another surprise waiting for them. Voyager saw it aligned perfectly with the Sun's magnetic field inside. Same alignment, just outside. Voyager 2 confirmed this wasn't a fluke. So what's causing this alignment? Scientists think it's about how the interstellar field drapes around the heliopause, like wrapping cloth. It matches the Sun's halo as they meet. Models show that in certain areas, magnetic reconnection, where magnetic lines break and reconnect, helps twist the interstellar field to line up with the solar one. Voyager 2 revealed that the outer region is actually denser and colder than the heliosphere, and the particles from inside are slipping through into space, like leaks in a cosmic ship's hull. As for Voyager 1, it even helped solve a cosmic ray mystery. Models thought particle counts would peak at the heliopause, but Voyager saw something the scientists called the Voyager paradox. It turns out that our solar system doesn't have a clean, empty edge. It has a shockingly hot, magnetic, and complex boundary where the Sun's influence meets the galaxy. Voyager has proven that space isn't just static and cold. It's dynamic, turbulent, and unpredictable. We've cracked open the curtain and peeked at the weirdest frontier humans have seen, and we're still not even halfway through the story. Voyager 1 started acting strange back in November 2023. Its flight data system, which is like the spacecraft's brain, started sending a repeating pattern of gibberish. Normally, this system bundles up all the science data and engineering stats, like temperatures, voltages, and the spacecraft's heartbeat, and sent it to Earth in ones and zeros. But suddenly, the messages made no sense. Voyager 1's radio signal still reached Earth, but it was a steady "I'm alive" ping without any useful info. After months of trial and error, they discovered the culprit, a single, stubborn memory chip that had gone rogue and corrupted about 3% of the system's memory. Nobody knows why it failed. Maybe it was just worn out after 4 decades, or a high-energy particle from deep space hit it like a cosmic bullet. Since they couldn't replace the chip, NASA engineers had to pull off some scientific magic to fix this 46-year-old gadget. They divided the missing code into pieces and carefully moved them to other memory spots on the spacecraft. A radio signal takes 22.5 hours to reach Voyager 1, and another 22.5 hours to come back. So, NASA engineers were sending messages into the void and waiting almost 2 full days to see if it worked. On April 20th, Voyager finally responded with readable, coherent data. It was like getting a text back from a friend who's been ghosting you for months. Except this friend is 15 billion miles away, floating at the edge of the solar system. Voyager 1, as well as its twin Voyager 2, was originally meant to last only 5 years. Both have gone through many challenges over their long journey. For example, a 7-month blackout in 2020 for Voyager 2, and a 2023 antenna mishap that required a shout command to get it pointed in the right direction. But despite all that, they're still working hard and sending back extremely important data. Voyager 2 zoomed past Uranus back in 1986 and sent us pictures and data from billions of miles away. After looking at that data, scientists thought Uranus wasn't giving off much heat, which is weird for a giant planet. But now, thanks to years of spacecraft observations and fancy computer models, researchers have found Uranus does have its own internal heat. It's just subtle, only about 12.5% more than the sunlight it gets. That means the planet is slowly shedding leftover heat from its birth, like a giant cosmic radiator cooling down after a super-hot childhood. Its long 20-year seasons and tilted spin make the heat fluctuate. Figuring this out helps scientists understand how planets form, how atmospheres behave, and even give hints about Earth's climate. Voyager 2 might have just shown us a frozen, quiet world, but decades later, that data helped uncover a secret heartbeat under Uranus's icy blue clouds. As you can see, space loves plot twists. Let's hop to Saturn's tiny moon, Enceladus. Scientists believe there's a massive ocean hidden under its frozen shell, and this moon's core is keeping it warm. Enceladus is small, about the width of Arizona. but it's one of the most promising places to look for extraterrestrial life. And that's because NASA's Cassini spacecraft caught it, spitting. Giant geysers of water were shooting out from cracks in its icy surface. Not only plain water, though. These plumes contain salts and organic molecules, including carbon, hydrogen, nitrogen, sulfur, and oxygen. These are the building blocks of life. And then, they also found phosphorus there. It's the rarest of the 6 elements upon which life depends. Together with sugars, it forms a skeleton for DNA molecules. The amazing part is that the concentrations of phosphorus on Enceladus are at least 500 times higher than the highest known concentrations in our oceans. Scientists also study the ice from Enceladus. Plumes of water vapor freeze into snow on the surface here, and they found it might not be all shapeless dust like they thought. Up to a quarter of this ice can form tiny crystals, hiding like chocolate chips in cookie dough. They ran simulations, froze virtual water at crazy speeds, scrambled molecules, and even tested real ice with X-rays. Some ice is so odd that it has the same density as liquid water, so it neither sinks nor floats. It's all critical to know, as space ice could shield spacecraft, serve as fuel, or even show how building blocks of life travel to Earth. Scientists haven't found life or something life might have created on Enceladus yet. But it looks like if we find life anywhere in our solar system, this moon will be the first in line. Or maybe we'll hear some exciting news from the Voyagers before it happens. They are still out there right now, flying through interstellar space. And some people are worried they could get damaged when they finally pass through the Oort cloud. Scientists haven't seen it directly, but many comets that visit us come from that region of space, stretching far beyond the Kuiper belt. The astronomer who supposed the cloud was real said it could contain around 100 billion comet-sized objects. Their total mass could be as heavy as Earth's. Sounds dangerous to the Voyagers, but no worries. Scientists say the odds of them getting damaged are 100,000 times lower than your chances of winning a lottery jackpot. Oh well. So the Voyagers will keep sending faint signals for a few more years before their power runs out. After that, they'll just keep traveling. Now, scientists have a wild theory. What if our entire universe is actually inside a black hole? This is called the black hole cosmology. Some scientists have the idea that our observable universe and everything we see around us might be tucked inside a black hole, which exists inside another parent universe or even multiverse. And then this multiverse could be part of a bigger one, and so on. Kind of like a stacking doll. Sounds like pure science fiction, but this is based on some curious facts. When scientists create the timeline of our world, they say that everything started from a singularity. If you kept squeezing a giant ball smaller and smaller, at some point it would get super dense before it crushed. Well, it's hard to imagine, but in space, it's possible to squeeze a crazy amount of mass into a teeny tiny point. This point is called a singularity. The matter gets crushed into an infinitely small space, less than an atom, and it holds all the same mass of everything, while taking basically no volume. Inside this singularity point, things get so intense that the normal rules of physics just stop working. Everything we know, time, space, matter, breaks down and can't be applied anymore. Basically, what happens from now on is beyond our understanding. So, scientists say that this was the starting point of our world. When the Big Bang happened, it's like this tiny dot with everything inside it expanded to everywhere. This started forming the universe as we know it. And here's the thing. Scientists assume that singularity also exists deep within black holes. General relativity says that a black hole is born when something really big, like a huge star, collapses under its own weight. Gravity gets stronger the bigger the mass is. With a mass of a huge star, tens of times bigger than our Sun, this tiny point would have an unbelievable gravity. It's why it starts sucking in all the stuff around it and curves the fabric of space-time so much it looks like a hole in space. And this would be the center of a black hole. It's a dot where all these things fall into and get crushed into an infinitely dense point. So, could our universe itself be just a little singularity dot inside a huge black hole inside of another universe? Well, that would be wild. So it's not that easy to compress something so much that it literally warps space-time. You'd need to squeeze it like crazy. If you wanted to make a small black hole like a human size, you'd need to shrink them down to the size of an atomic nucleus. If you want a black hole the size of a chickpea, you'd have to compress our entire planet to that. But our universe is 99% empty space. There are trillions of miles of just nothingness between the stars. If you were to pack all the matter in the universe together, the result would be surprisingly small. Everything around us, including galaxies, stars, planets, and dust, would only fill about 1 billion cubic light years. It would be a cube about 1,000 light years on each side. For comparison, our Milky Way alone is 100,000 light years in size. That's how sparse the universe is. But at this density, it would also be very, very massive. The resulting mass would likely collapse into a black hole. And here's the wildest part. The resulting black hole would be roughly the same size as the universe itself. It would also have the same mass and energy, as well as the same average density. The size or radius of the black hole grows together with its mass. The more stuff it eats, the bigger it is. But the density works the other way around. The black hole gets less dense as it grows. For a size that big of our entire world, it would be pretty sparse as well. And it's not the only coincidence. We have this thing called the Hubble radius, also known as the cosmological event horizon. If we imagine our observable universe as a giant bubble, then think of its edge like the farthest part of the universe we can see. When you stand in a field and look around, trying to see as far as you can, your eyes will draw a circle. This is like that. There might be more beyond that point, but we'll never know. Beyond this horizon, the light from distant parts of the universe will never reach us. That's because light travels at a certain speed, and the space between us and those regions is expanding too quickly. It's like running towards something while super strong winds try to blow you away. Until we stay on Earth, we're cut off from those far-off corners forever. The black holes have something eerily similar called an event horizon, or the Schwarzschild radius. This is the point of no return. This is the imaginary line that's often depicted as a light contour around the black holes. Anything crossing an event horizon, falling inside, is lost forever. No light, no matter, no information can escape from there. Black holes' gravity is way too strong, so they're perfect space vacuum cleaners. And as we mentioned before, if we create a black hole the size of the universe, they would have the same mass and the same event horizon radius. Now, while some scientists think this could just be random coincidences, others believe it's a clue that our universe might actually be inside a black hole. The theory also suggests that our universe might not be the only one. It could exist in one of many black holes scattered throughout a large multiverse. In this crazy model, each one of them, both in our world and our parent world, could lead to its own universe, with its own set of physical laws and structures. Now that would be some weird chain. There's this theory that says that universes could be born inside of black holes, sort of. It's called the Einstein-Cartan theory. This idea talks about singularity as well, but in a different way. It says that instead of collapsing into an infinitely dense dot, the matter might create a wormhole. This is like a tunnel through space and time. This wormhole, also known as an Einstein-Rosen bridge, could connect two different places of our universe. In that case, one side of the tunnel is the black hole, and on the other side, there would be a whole new universe forming. So it could work like a teleport. As soon as you pass the event horizon, you travel to the new world. But in that case, there should be an exit. Some scientists made it up and called it a white hole. It doesn't literally exist, not as far as we know, but it could be possible somewhere on the other side. It would serve as an exit of a wormhole, an area where matter is always ejected instead of pulled in. So it's like you can't throw anything in there, it would get expelled immediately. That's all purely hypothetical, of course. All this stuff fits well into the concept of the Big Bounce. This idea says that instead of our universe beginning with a singular Big Bang, it bounced from a previous state of collapse. Remember the squeezed ball analogy? Well, maybe there used to be another universe ball that got super compressed to a minimum size before rebounding and expanding again. So instead of a universe born from nothing, we might live in one that's a cosmic recycling of another. There's also another version of this theory, sometimes called shockwave cosmology. The idea says that the Big Bang could have been caused by a boom inside a black hole, and this could create the expanding universe we see today. As the universe expands and the matter density decreases, the black hole would eventually transform into a white hole, the reverse of a black hole, where matter is expelled instead of pulled in. But even though we have all these interesting connections, they're not evidence. There are no experiments or observations that could prove or disprove these wild theories. So they all remain speculation for now. But at least it's fun to speculate.
Black holes tearing apart enormous stars, pulsars spinning at incredible speeds and emitting powerful beams of energy, colorful nebulae with fireworks of newborn stars, galaxies of every possible color and size. All of these are found within our universe, but it's not infinite. It has a boundary, a literal wall, and beyond that, there's an absolute nothingness. Right now, we're going to make a journey to that wall. But first things first, our universe is like a humongous nesting doll. If you open it up, there's a smaller one inside. It's a galaxy. Inside that is an even smaller doll. That's our solar system. And the smallest doll of all is the Earth. Each of these dolls has boundaries that we're going to cross. For that, we'll need a spaceship, and a big one. It also has to be able to move 100 times faster than the speed of light. You get on board and start the engines. 62 miles above sea level is our first boundary. That's 10 times higher than passenger planes fly. This point is called the Kármán line. It separates the atmosphere of the Earth from outer space. Now we fly further to the edge of our solar system. We turn on the hyperdrives and fly past Mars, Jupiter, Saturn, Uranus, and Neptune. We've traveled a distance of 100 astronomical units. 1 AU is the distance from Earth to the Sun. And here's the boundary of our solar system, the heliosphere. Here, the speed of the solar wind decreases rapidly. First, it drops from 620,000 miles per hour to the speed of sound. Then, there's a layer called the heliopause. This is where the wind almost vanishes. And then, our ship experiences a bow wave. This is where we feel the force of the interstellar wind, which collides with the boundary of our solar system. When you pass this boundary, you find yourself in the dark of interstellar space. And here, you can find two human-made objects that made this trip for the first time in history. They're Voyager 1 and Voyager 2. Voyager 1 crossed that boundary in 2004. Voyager 2 did it in 2007. These space probes discovered that the heliosphere is not a perfect ball around the sun. Its southern boundary is 10 AUs closer to the star than the northern one. So, we're moving in interstellar space and will soon approach a stone wall around our solar system. 200,000 AUs further, and there it is. This wall of rock is the Oort cloud. In fact, it's a pile of asteroids that surround our world. Scientists speculate that the Oort cloud could be the source of comets and meteorites that fall to Earth, but they're so sparse that we easily fly between them. Now we're in complete darkness. The Milky Way is about 106,000 light-years wide. In a conventional rocket, it would take billions of years to fly across that distance. But you throttle to the max. You masterfully fly past the stars and planets as if on a racetrack. And within minutes, you're at the edge of our galaxy. There's no more interstellar wind. All you see are bright dots somewhere in the distance. These dots are huge galaxies. We need to look at a map to make a route to the edge of our entire universe. You're here, near the Milky Way galaxy. It's part of a cluster of galaxies called the Laniakea supercluster. But even this huge thing is like a little street in a big city. Zooming out, we find Hydra Centaurus supercluster. Thousands of galaxies on the map look like little dots. Maximum zoom out. This is our entire observable universe. We thought it was infinite, but we may have proof that it has a boundary. It's here, 10 billion light years away from our home. Even if you travel at the speed of light, a trip there would take twice as long as our whole planet has existed. During that time, the sun will either fade away or explode like a supernova, destroying our entire solar system. And if you can live that long and then return home, you will see that our galaxy is there no more. It's long since collided with the Andromeda Galaxy and merged into one big cosmic body. Luckily, your ship is able to warp space-time so that this journey will literally take a few seconds. Boom! Congratulations! You've arrived at your destination, the Eridanus supervoid. Some scientists believe this location is the evidence of collisions of our universe with something big enough to leave such a large scar. The Eridanus supervoid is an empty and cold space 1 billion light-years wide. If you think of this void as a cup, it would fit at least 10,000 galaxies, and it appeared after an accident of gigantic proportions. The object that crashed into our universe was another universe. Yes, other universes may actually exist. Imagine that our entire universe is a huge bubble that contains all the clusters of galaxies in the observable universe. There could be an infinite number of such bubbles. They could have been born during the Big Bang. These universes may be different from ours. They may have other galaxies and nebulae. But these bubbles could also be parallel universes. This means that if you chose cereal over oatmeal in the morning, in another universe, your twin would choose the oatmeal. Every choice you ever made in life had completely different consequences in a parallel universe. And because the number of choices are infinite, there's a whole infinity of parallel universes. So, like a regular bubble, our universe has a wall that is near the Eridanus supervoid. Long ago, another bubble flew past ours. As they approached each other, their gravitational fields began to interact. Our boundary wall began to deform and pull toward the other universe. The same thing happened on the other side. Then the walls of our universes came into contact. But as these bubbles moved, their connection began to break, and the other universe just ripped a huge chunk of ours. A cold void was formed at the point of collision, and that was the Eridanus supervoid. The problem is that the universe looks the same to the observer, regardless of point of view. For example, imagine a basketball hanging in the air. Now, if we put an ant on the ball and tell it to find the edge of the ball, it will start running around it, making an infinite number of circles. But the landscape around the ant will not change. All it will see is a rounded horizon. That's because the ball remains the same from any point of view. The same thing happens to us when we try to find the edge of our universe, all because we imagine the world in three-dimensional space, and our view is limited. For example, you see an ordinary square in two-dimensional space, but if you add depth and change the point of view, voila, it's a cube. If we could see the universe in four-dimensional space, a square might be something completely different. But maybe we can leave our home bubble. The key to traveling to another universe might be inside a black hole. A black hole is one of the most mysterious objects in the universe. They're so heavy, they warp not only space, but time as well. It's like putting a heavy boulder on a net. The net will sag, and the closer you get to the boulder, the stronger the curvature is. Once you're in the gravitational field of a black hole, you can't leave it. We still don't know what might actually be in the heart of a black hole. Some scientists speculate that white holes also exist. Theoretically, they should be born along with black holes. Except for the color, they're the exact opposite of black holes. Nothing can come close to a white hole. At the moment, there's no data on such objects, but general relativity theory suggests they do exist. There's also a theory that a black hole may be a passage to another universe. When you get into a black hole, you can come out the other side through the event horizon of the white hole. So you bypass the boundary of the universes and find yourself in a completely different world. But we may have proof that a white hole exists. In 2006, scientists discovered an unusual burst of energy somewhere 1.6 billion light years away from Earth. This burst was unique. It didn't look like a supernova explosion or even the merger of two black holes. Some astronomers believe it was the birth of a white hole. But because it was unstable, it was destroyed almost immediately. This process was reminiscent of the birth of our entire universe, the Big Bang. So, scientists called it the Little Bang.
Our universe is like a giant highway, and galaxies are constantly moving along this highway. And just like cars driven by careless drivers, they can collide and crash. So, astronomers have recently witnessed such an incredible cosmic collision. It involved galaxies traveling at incredible speeds. Using advanced instruments, researchers clocked one galaxy traveling at a speed of around 2 million miles per hour as it crashed into a group of other galaxies. This collision has created shock waves that are so powerful they can completely reshape the entire region, leaving long-lasting effects on its structure and dynamics. Will it somehow influence our solar system? Before we find out, let's learn more about the region where this collision occurred. Actually, this collision is still happening in Stephan's Quintet. That's a fascinating cluster of galaxies that has been the subject of study for scientists for over a century. It's a group of 5 galaxies located in the constellation Pegasus. This group of galaxies was first discovered in 1877 by the French astronomer Édouard Stephan, who used a telescope at the Marseille Observatory. Despite its tranquil name, Stephan's Quintet is anything but peaceful. It's a chaotic spot filled with galactic collisions and turbulence. 4 out of the 5 galaxies are gravitationally bound. It means they are physically interacting with one another. Such interactions are ejecting material from the galaxies, and over time, it forms vast debris fields in the space surrounding the galaxies. Astronomers believe that, in the end, these galaxies will merge into one giant galaxy, but it will only happen in millions of years. The curious thing, though, is that the 5th galaxy in the quintet, located in the upper left corner of images, is not part of the collision. This galaxy is much closer to Earth, more than 200 million light-years closer, to be precise. So its alignment with the other galaxies is just a chance perspective from our vantage point, making it appear as part of the group. Stephan couldn't know this in the 19th century, so the name Quintet has remained, even though only 4 galaxies are physically involved in the collision. Now, how about we look at this collision in detail? At the center of this event is one of the galaxies in the group, which is currently crashing into the others at a breathtaking speed. From our perspective on Earth, this galaxy appears to be approaching the quintet from behind, heading directly toward the viewer. The collision is creating a massive shock wave that ripples through the surrounding galaxies. As the shock wave is moving through packets of cold gas, it's traveling at hypersonic speeds, several times the speed of sound in the intergalactic medium. This process strips electrons from atoms, leaving behind long trails of glowing ionized gas. But when the shock wave comes across regions of hot gas, it compresses the material rather than disrupting it. This compression produces radio waves, which can be detected by radio telescopes. While reshaping the structure of the intergalactic medium in Stephan's Quintet, this shockwave also influences the future evolution of the galaxies involved. Now, how did scientists even manage to spot such a dramatic space event? All thanks to innovative technologies. The most important participant was WEAVE, a cutting-edge spectrograph that's installed on the William Herschel telescope in La Palma, Spain. This tool specializes in gathering spectroscopic data, which is the information about how matter absorbs or sends out light and radiation. It allows astronomers to examine the movement and composition of space objects with great precision. Besides WEAVE, researchers have used data received from a few other large observatories. One of those was LOFAR, Low Frequency Array. It's a radio telescope with an antenna network observing the radio waves the weaker shock wave produced while compressing hot gas. Astronomers combined the data received from all these instruments and managed to study the shock waves and their effects in amazing detail. This collision in Stephan's Quintet gives us a fantastic opportunity to find out more about the interactions between galaxies, which can influence the evolution of the universe. You see, when galaxies crash into each other, their gas and dust gets redistributed, and it can trigger the formation of new stars and even cause central supermassive black holes to grow. And if we talk about Stephan's Quintet, the ongoing collision in this area helps us get additional information about the behavior of gas under extreme conditions. Now, at the same time, galactic collisions aren't as rare as you might think. They're common on a cosmic scale, and in the early universe, collisions occurred even more frequently because galaxies were located much closer together. With time, such interactions have played a key role in shaping the universe. Even our own galaxy, the Milky Way, has experienced tons of past collisions. We can see the evidence of such destructive interactions in the form of debris streams and disrupted star clusters within the galaxy. In fact, astronomers predict that the Milky Way will collide with the neighboring Andromeda galaxy in about 4.5 billion years, eventually forming a new, larger galaxy. Even though they're moving at incredible speeds, galactic collisions are super slow processes from our human point of view. While galaxies may travel at millions of miles per hour, the distances they cover are so vast that mergers take millions to billions of years to complete. Now, galactic collisions don't look like explosive crashes you might be imagining. Instead, they resemble when fluid merges. When two galaxies collide, their gravitational forces distort their shapes. They stretch and warp, and exchange their material, stars, gas, and dust. As a result, tidal tails, rings, and even bridges between galaxies form. One of the most famous collisions between galaxies is ARP-148. During this cosmic crash, one galaxy became shaped like a ring, while the other stretched in a long tail-like form. That's how powerful gravitational interactions between galaxies during collisions are. But however impressive intergalactic collisions are, collisions between neutron stars, those ultra-dense remnants of massive stars, are among the most energetic phenomena in the universe. Neutron stars are incredibly small and dense. Just one contains the mass of our Sun packed into an area the size of a city. When two neutron stars collide, they often merge to form a black hole, releasing immense amounts of energy in the process. These events produce gravitational waves, ripples in space-time, that can be detected by instruments like LIGO and Virgo, as well as bursts of light that outshine billions of stars. On Earth, the possibility of a galactic collision directly affecting us is extremely low. Luckily, the timescales and distances involved make such events harmless to life on our planet. However, smaller-scale collisions, such as an asteroid impact, are more plausible. Asteroid impacts have occurred in Earth's history, and the most infamous of them caused the extinction of the dinosaurs 66 million years ago. And while large impacts are rare, astronomers closely monitor near-Earth objects to protect our planet from potential threats. Now, while we're talking about space collisions, a question may arise. Can life travel between planets? This is the idea of lithopanspermia, the transfer of life between planets via debris from collisions. If an asteroid or comet hits a planet, fragments of rock could be ejected into space. If those fragments carry microbial life, they might land on another planet and seed life there. And guess what? According to experiments, certain super tough microorganisms like cyanobacteria could survive the harsh conditions of space travel, including radiation and re-entry into the atmosphere of another planet. In any case, lithopanspermia is still only a theory and a controversial one among scientists, but it doesn't make it less fascinating. It might eventually help us understand how life could have spread across the universe. But let's return to the ongoing collision in Stephan's quintet. By studying such events, astronomers learn more about how galaxies interact, evolve, and influence their surroundings. Hopefully soon, we'll find even more interesting facts about this process. Stay tuned. Guess what? The universe can get actual scars, just like when you fall off a bike. Well, here's why. Before the Big Bang, the universe was extremely hot, dense, and full of energy, and it seemed like everything was going well, until that all changed about 13.8 billion years ago. Then the universe exploded. After the blast, it expanded incredibly quickly. Our human brain can't even perceive how fast that expansion was. Sometime later, the universe started cooling down. As it did, giant, terrifying scars cutting through space-time appeared all over the place. And if we study these scars well, we can even get insight into time travel. These days, we call these scars cosmic strings. They're like stretch marks that appear when the skin expands too quickly. Or we could also compare them to cracks that form in the ice when it freezes. These strings are likely very thin, about the size of a proton, a positively charged subatomic particle. Yes, subatomic means smaller than an atom. The strings are also extremely dense and can stretch for light years. Now imagine these cosmic scars floating through space, not interacting much with their surroundings. When two cosmic strings pass each other, they could warp space-time in such a way that it creates a time machine. If you were to travel along a certain path around these strings, you would end up returning to your starting point at an earlier time, which is traveling back in time. Now, let's admit it, this idea sounds like something from science fiction, but it's supported by cosmic string theory, and the math behind it seems to work. Unfortunately, no one has observed cosmic strings yet, so for now, it's still a theory. In 1991, one physicist proposed an idea for how cosmic strings could enable time travel. If two infinite cosmic strings passed each other in parallel, they would warp space-time, creating a time loop. This loop would allow someone to travel back in time. Even better, this idea doesn't contradict Einstein's theory of general relativity, which suggests that large objects can bend space and time. These bends in space-time could allow a shortcut through time. His now well-known concept of closed time loops also helps explain how wormholes might work. So, a wormhole is basically a theoretical tunnel connecting one place in space to another. Some people believe that by using such tunnels, we could create shortcuts for incredibly long journeys through the universe, which would allow us to visit other star systems and galaxies. So, let's say you manage to create a wormhole and even accelerate one of its ends to near the speed of light, and then you send it back to where it came from. Well, at that moment, those two ends are not synced anymore. One is in the past, while the other is in the future. And if you somehow manage to walk between them, you'd be time traveling. You could do something similar by placing one end of the wormhole near a powerful gravitational field, like a black hole, and keeping the other side near a weaker gravitational force. This way, according to the theory of relativity, time would pass more slowly nearer to the strong gravity side, and it would allow a particle or another chunk of mass to remain in the past relative to the other side of the wormhole. At the same time, if you decided to create a wormhole, you'd have to keep in mind that they are super dangerous. They might collapse all of a sudden. They're likely to be highly radioactive, or you could come into contact with toxic exotic matter inside. But let's get back to the math behind the cosmic string time machine idea. Admittedly, it is solid, but it doesn't mean such a time machine is possible yet. To use this way of time travel, we'd need to reach near light speed, and it might be impossible. According to Einstein's relativity, the faster an object travels, the more energy it needs to continue speeding up. In other words, we don't yet have the technology or energy sources to accelerate a spacecraft to these speeds. The idea of two infinite cosmic strings is also questionable because we can't create something that's infinitely long. So, while this time travel model is mathematically sound, the infinite nature of the strings would make this exact model impractical. At the same time, some scientists still believe that cosmic strings are a better possibility than most other models, like wormholes. In any case, before we can start considering time travel, we need to discover cosmic strings. Luckily, there's a group of astronomers working to detect low-frequency gravitational waves by measuring signals from a type of star called a pulsar. Now, pulsars send out regular pulses of radio waves, and by measuring small changes in the timing of these pulses, scientists can detect subtle shifts in space-time. Those changes are caused by gravitational waves, which are ripples in space-time. Now, so far, we've only detected gravitational waves coming from black holes. But in 2020, there was one strange signal that didn't look like it came from black holes. It could be coming from cosmic strings. And here, we need to mention string theory. According to it, the universe is made up of more than just the 4 dimensions of space-time. There are additional dimensions that are hidden from us. Plus, the basic building blocks of the universe aren't particles. but tiny vibrating strings. These strings can vibrate at different frequencies to create different fundamental particles. These strings, from string theory, could have stretched out during the early universe and become the very cosmic strings we've discussed. In the coming years, we might get more information about them from a space-based gravitational wave telescope called LISA. It's supposed to launch in 2035. But if the signals picked up in 2020 really came from cosmic strings, it could mean a huge breakthrough in physics. In this case, string theory would become the right framework for understanding the universe. It would completely change the way we think about the building blocks of our reality. On the other hand, even if the signals don't turn out to be from cosmic strings, this discovery would still be important. It would give scientists more information on what cosmic string signals might look like in the future. And while we're not yet at the point of time travel, the discovery of cosmic strings could take us one step closer to understanding the mysteries of the universe and maybe even the possibility of traveling through time. Now, time travel is a popular theme in science fiction, but in fact, moving forward in time happens naturally. Right now, you are traveling into the future at a steady rate of 1 second per second. However, scientists have discovered that this rate can change depending on speed and gravity. Einstein's special theory of relativity explains that time slows down as an object moves faster. The closer you get to the speed of light, the more slowly time passes for you, compared to someone who isn't moving at all. The general theory of relativity adds another factor: gravity. The stronger the gravitational pull, the more slowly time moves. Near massive objects, such as the surface of a neutron star, black hole, or even Earth, time runs more slowly than it does far away from these space objects. If someone were to stay near the edge of a black hole, where gravity is incredibly strong, only a few hours might pass for them, while thousands of years would go by for people on Earth. If they returned, they would have effectively traveled into the future. This is a real and scientifically proven effect. A real-life example of time travel, though on a tiny scale, can be witnessed in space missions. For example, this cosmonaut spent a total of 748 days aboard the space station Mir during 3 separate missions. Because Mir was moving at high speeds relative to Earth, it experienced time dilation. As a result, he aged 0.02 of a second less than had he stayed on the ground. Now, this difference may seem tiny, but it shows that time moves differently depending on speed and location. But while traveling to the future is scientifically possible, traveling to the past is much more complicated and controversial, and leads to logical paradoxes. Imagine you throw a billiard ball into a time machine. It travels to the past and collides with its earlier self. This prevents the ball from ever entering the time machine in the first place. A contradiction.
It's been more than a year since the James Webb Telescope, which had taken over 20 years to complete, was launched. And for such a relatively short time, the ultra-modern and most powerful in history piece of equipment has already made plenty of discoveries. By observing the universe at infrared wavelength, James Webb lets us see things no other telescope has ever shown before. The primary goal of this incredible piece of equipment is to study the formation of galaxies and stars that appeared in the early universe. For example, look at the closest to us stellar nursery, a region of space where new stars get born. NASA has shared an image from James Webb that shows a small star-forming region. If you look at the picture attentively, you'll see jets bursting from infant stars. Around them, different colored clouds of cosmic dust are colliding with one another. The view is mesmerizing. The red dust consists of molecular hydrogen. You can also notice that some stars have something like shadows. Those hint at the creation of what will later become planets. At first sight, the image may seem chaotic, but astronomers claim that it's a relatively small and quiet stellar nursery in comparison to some others. Many young stars there are similar in size to our Sun, or a bit smaller. The photo itself was taken with the help of Webb's near-infrared camera, NIRCam. It's the observatory's primary camera that snaps images of the cosmos in 2 different infrared ranges. Another amazing discovery the Webb telescope has made is smoke molecules in a distant galaxy. It's the first time such molecules have been discovered so far away from our planet. The galaxy in question lies 12.3 billion light-years away from Earth. It most likely formed about 1.5 billion years after the Big Bang. Despite such a huge distance between the galaxy and our planet, scientists have managed to detect chemical compounds found in soot or smoke, and it's quite a big deal since it has pushed the record for detecting similar complex molecules back by around 1 billion years. This study has also confirmed the sheer power of the coolest piece of space equipment of all time. It managed to make this discovery despite the fact that the spectrometer needed for the measurements didn't perform to the fullest after having experienced a sudden and surprising degradation. The James Webb Telescope has also helped to boost our understanding of exoplanets. Those are planets orbiting stars other than our own sun. At the beginning of 2023, the observatory spotted its first exoplanet, LHS 475b. It's located 41 light-years away from Earth and is approximately the same size as our planet. According to NASA, nowadays, James Webb is the only operating telescope capable of categorizing the atmosphere of Earth-sized exoplanets. The research team behind the discovery believes such results underline the precision of the telescope. They hope that it will help us locate many more rocky exoplanets that we might be able to colonize in the future. Even though, at first sight, it may seem that the universe is pretty empty, it's actually a very busy place, and Webb has all the necessary instruments to see all kinds of cosmic events happening out there. Just look at this image of WR-124. It's a star on the cusp of its explosive demise. In the image, the star is about to go supernova. It happens when a star runs out of its fuel and explodes at the end of its life cycle, releasing a giant cloud of space dust and hot gas into space. The star captured by the Webb telescope was at the Wolf-Rayet stage of its life. That's a period when a star is shedding its outer layers before going supernova. The next amazing thing discovered by James Webb is a star-planet hybrid with very strange clouds. This bizarre world, VHS 1256b, is actually a brown dwarf. Those are bigger than planets but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us, it appears to be dark orange or magenta. The brown dwarf discovered by the Webb telescope is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars, and to complete one orbit, it needs over 10,000 years. Astronomers first found out about this unusual exoplanet in 2016, but at that time, they didn't classify it as a brown dwarf, and, thus, couldn't explain its puzzling reddish glow. Now, thanks to the James Webb telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor. But those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Another recent discovery involves several large galaxies that scientists believe were born not long after the Big Bang. They aren't supposed to be there, and no one expected to find them. But the James Webb Space Telescope has spotted them. These galaxies, as massive as our home Milky Way, are full of mature red stars. Astronomers have analyzed the light coming from them and estimated their age 500 to 700 million years after the Big Bang. It means that they came into being when our universe was very young, almost a baby. But the most bizarre thing about these galaxies is their tremendous size and the age of the stars dwelling there. The data received by the telescope don't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. It also doesn't match the earlier observations made by Hubble. And here, James Webb has captured a distant region of space in unprecedented detail. This section of space is known as Pandora's cluster. In the image, you can see 3 massive clusters of galaxies coming together and forming a megacluster. The combined mass of these clusters acts as a powerful gravitational lens. And thanks to this natural magnification effect, scientists can see other galaxies in the region. Astronomers claim that the most recent image of Pandora's cluster is stronger and deeper than they have ever seen. James Webb has also managed to spot thousands of young stars never seen before in the Tarantula Nebula. This space formation got its nickname because of the appearance of dusty filaments spotted in previous images. It's the biggest star-forming region in the local group, which includes the galaxies nearest to the Milky Way. The Webb telescope's images have helped to shed light on the composition of the Tarantula Nebula. The telescope has also detected protostars, infant stars in the process of gaining mass. Astronomers expect that these protostars will eventually form and shape the nebula further. Among other discoveries made by the James Webb telescope, you can see the birth of 50 distant stars. Some of them power protoplanetary disks, which might later form solar systems light years away from our own. Here's one more image from James Webb. You can see a supermassive black hole that has a mass of 9 billion suns. It's so ginormous and ancient that scientists are struggling to explain its existence. Astronomers have also discovered a distant ring of dust, rock, and gas that contains a chemical called methylcation. It's known as a molecular building block of life, and it makes most of the organic material on our planet. James Webb helped researchers see powerful sandstorms on a planet 235 trillion miles away. Astronomers were happy to discover this treasure chest of countless tiny sand particles. Now look at this. Do you recognize this image? Those are the so-called pillars of creation. But this new view shows us just how star-speckled that dusty region actually is. You can compare the new photo with the one taken by Hubble in 2014. This is astonishing proof of scientific progress.
The James Webb Telescope, or JWST, is like the ultimate intergalactic paparazzi. It takes pictures of some of the most famous celebrities in the universe. Stars, galaxies, exoplanets, you name it. The James Webb Space Telescope will snap a photo. So if you're a fan of cosmic celebrities, let's take a look at some of these best star-studded photos. The Carina Nebula. The image of the nebula with the beautiful name Carina was published on July 12th. JWST captured a beautiful view of the nebula, located about 7,500 light-years from Earth. Nicknamed the Cosmic Cliffs, it is, in fact, a hotbed of young stars, some of which are several times larger than our Sun. The Carina Nebula is a celestial spectacle located in the southern constellation Carina. It's really huge, approximately 260 light-years across. Massive stars within this nebula are so bright and hot that they create a glowing cloud of gas and dust around them. The Carina Nebula also contains swirling clouds of gas and dust where new stars are being born. The gas collapses under its own weight, becomes hotter and denser, and all this eventually leads to the creation of new stars. However, the Carina Nebula isn't just some peaceful place of star formation. It's the site of some of the most destructive events in the universe, which create massive shockwaves that obliterate everything in their path. Very chaotic and cool. The Stephan's Quintet. This photo was also posted on July 12th. Stephan's Quintet is a visual group of 5 galaxies located at a huge distance from us. About 290 million light-years in the constellation of Pegasus. It's like a cosmic family reunion. All these galaxies are related to each other and interact with each other in some interesting ways. They're pulling and tugging on each other with their gravity, constantly exchanging gas and dust. This interaction is causing some of the galaxies to collide and merge, which can create all sorts of cool effects, like bursts of star formation and supernovae. Thanks to JWST, we were able to see shockwaves, tidal tails, and other amazing details about these galaxies. Their interactions create a stunning sight that we can see in this photo. Jupiter. And here's our old giant friend. This image was published by NASA on August 22nd. Jupiter is the largest planet in our solar system, and it's known for its many moons and its beautiful swirling clouds. But it also has a system of rings, just like Saturn, which are made up of tiny particles of dust that orbit the planet. These rings are much smaller and less visible than Saturn's, but they're still pretty neat. Jupiter also has auroras, which are colorful light displays that occur in the planet's atmosphere. They're caused by charged particles from the solar wind interacting with Jupiter's magnetic field. Just like on Earth, they can be seen near the poles of the planet. But these auroras are much brighter and more intense than ours. We can even see this crazy light show from space. And now, we were finally able to capture this dazzling sight. JWST's photo shows the auroras of Jupiter, its rings, and even two moons, Amalthea and Adrastea. It's amazing how bright and clear they are on this photo. The Cartwheel Galaxy. NASA released this image on August 2nd. This photo shows us the Cartwheel Galaxy and its companions. The Cartwheel Galaxy gets its name from its shape. It kind of looks like a cartwheel, doesn't it? This is a giant swirling mass of stars, gas, and dust, which is located in the depths of space. It's shaped like a pinwheel with long spiral arms. These arms are held together by the gravity of the central region, which is home to a supermassive black hole. But the Cartwheel Galaxy is a bit different from its spiral relatives. It has formed when a smaller galaxy collided with a larger one, creating a shockwave that rippled through the gas and dust. We'll definitely have to visit this galaxy someday. It's sure to be a wild ride. Spiral Galaxy M74. And here comes another spiral galaxy. NASA released this image on July 22nd. JWST had to peer through thick layers of dust and gas to see this beautiful star cluster. M74 belongs to a special class of spiral galaxies known as the Grand Design Galaxy. This means that its spiral arms are noticeable and clearly outlined. All sorts of amazing things are happening inside of spiral galaxies. Supernovas, stars being born in clouds of gas and dust, and many other cosmic wonders. The glowing gas and dust, the bright stars, and the swirling patterns of the spiral arms make them some of the most striking objects in the universe. Well, we can clearly see it on the example of M74. The Tarantula Nebula. This image of the nebula with a creepy name Tarantula was published on September 6th. The photo covers as much as 340 light-years across. This is a huge distance. Thanks to this image, astronomers have discovered new young stars that were previously shrouded in dust. The Tarantula Nebula is located 160,000 light-years away from us, in the Large Magellanic Cloud. It's the largest and brightest star-forming region in the local group, the galaxies nearest our Milky Way. It's named after its shape, which looks like a bit like the legs of a big tarantula. It's a vast region of space, about 1,000 light-years across, and it's home to some of the most massive and luminous stars in the universe. One of the reasons why the Tarantula Nebula is interesting to scientists is its composition. Its composition is close to the region of stars of the cosmic noon, the so-called state of our universe when it was only a few billion years old. At that time, star formation was at its peak. Thanks to the Webb telescope, we can study this galaxy better and find out what our universe was like at its peak. Neptune's rings. This photo was published on September 21st, 2022. In this photo, we can even see 6 small moons next to the planet, with Triton shining brightly in the upper left corner. You didn't think it was the sun, did you? And yep, Neptune has rings too. They're like the ultimate cosmic accessory. They add a touch of glamour and style to the planet. But unlike some earthly bling, these rings are made of small particles of dust rather than diamonds and gold. There are 5 known rings around Neptune: the Gall, Leverrier, Lassell, Arago, and Adam's rings. Scientists think that these are relatively young, much younger than our solar system, and much younger than, for example, Uranus's rings. They were probably created when one of Neptune's inner moons got too close to the planet and was torn apart by gravity. We haven't seen Neptune's ring so brightly since Voyager 2 flew past it back in 1989. So this is a great opportunity to take a closer look at these rings. The Pillars of Creation. This photo was published on October 19th. The Pillars of Creation became famous thanks to the Hubble telescope, but this photo is very lush and much more detailed. These columns, located in the Eagle Nebula, are about 5 light-years tall, which is really, really long. And they look like some majestic rock formations, only much more transparent. Just like a typical Hollywood movie set, they're full of action and special effects. They're home to some of the most dramatic processes in the universe. The gas and dust are collapsing under their own gravity, forming clumps that will eventually become stars. The place is full of intense radiation, jets of high-energy particles, and supernovae. It's like a cosmic version of Survivor. And if this wasn't creepy enough, here's another photo published by NASA on October 19th. They shared it right before Halloween. Here, the pillars resemble an eerie hand reaching for something. Brrr. Anyway, all these photos give us a truly awe-inspiring sight. They remind us of the incredible complexity of the universe and the amazing things that are happening even in the darkest and most remote corners of the cosmos. Let's hope that the James Webb Telescope will continue to amaze us in the future. Look at this comet. Recently, it's erupted 4 times in less than 48 hours and has become nearly 300 times brighter than normal. This is the most powerful set of eruptions the comet has had in over 3 years. Should we worry here on Earth? Well, I wouldn't say scientists are worried. They're super excited. First, let me give you a little background. 29P is what astronomers call a Centaur comet. Those are icy objects that orbit the Sun in the space between Jupiter and Neptune. What's interesting about centaurs is that they're kind of like cosmic hybrids because they're moving from one kind of space body to another. They start their life as far-out objects in a lifeless, freezing cold zone beyond Neptune. But then, over a few million years, they move inward toward the Sun because the planets of the solar system affect them with their gravity. Eventually, they turn into short-period comets. This term means they can pass close to the Sun and then slingshot back out into those icy regions. Centaurs, and their name indeed comes from a hybrid half-horse, half-human creature popular in Greek mythology, are especially interesting because they're basically leftovers from the formation of our solar system, kind of like cosmic fossils. Since they've been hanging out in the frigid outer solar system for so long, they've kept a lot of the volatile materials that were present when the solar system was first forming. This makes them a valuable clue in understanding how our solar system evolved. That's what makes scientists so enthusiastic. Now, about 29P itself. This thing is huge for a comet. It's about 37 miles across, which is almost 3 times the length of Manhattan. Now, worry not, it's too far away to cause us any harm. While it's one of up to 1,000 known centaurs, 29P is also in a rarer group of comets called cryovolcanic comets. Those are a fascinating class of space objects that have unique geological activity. The thing is, cryovolcanic comets not only contain a unique mix of ice, dust, and rock, but also feature cryovolcanoes, aka cold volcanoes. They erupt with volatile materials like water, ammonia, or methane instead of molten rock. As for regular comets, when they approach the Sun, the heat from the star evaporates their gases, leading to the emissions of dust and tiny particles, electrons, and ions. These materials create those magnificent trails. These eruptions are incredibly spectacular and make the comet appear a lot brighter since the cloud of cryomagma reflects the Sun's light. The cloud that forms around the comet is called the coma. and it can grow so large and bright that it makes the comet look like a fuzzy ball of light. If you've ever observed a comet, the coma is the halo you see around it. Such eruptions are pretty unpredictable. While most cryovolcanic comets follow elliptical orbits that take them far out into the solar system, 29P is on a more circular orbit, staying around the same distance from the Sun as Jupiter. You'd think that this would mean its eruptions would be more regular, but that's not the case at all. In fact, 29P erupts in a completely random and unpredictable way, and scientists are still trying to figure out why. The latest outbursts started on November 2, 2024, when 29P erupted for the first time in almost 2 years. This was followed by 3 more large eruptions in less than 48 hours, which really got the attention of astronomers at the British Astronomical Association. They'd been tracking 29P for a while, and they reported that the eruptions sent out a cloud of debris reflecting about 289 times more light than the comet's nucleus, which is a huge increase in brightness. Astronomers are expecting that the coma, which is growing after each eruption, could take on an unusual shape. The multiple outbursts might cause the coma to expand in a weird, irregular way. This is especially interesting because 29P hasn't had a major eruption like this since November 2022. Then it threw out over 1 million tons of debris. The last time it had a massive outburst was in September 2021, when the comet had multiple eruptions in quick succession. In addition to the confusion about its eruptions, 29P is pretty different from most other comets. Most comets have elliptical orbits that take them far out into the solar system. They spend decades, centuries, or even thousands of years far from the Sun, only to erupt when they get close. But 29P doesn't do that. No, it orbits the Sun once every 15 years and stays at about the same distance as Jupiter. This strange behavior makes astronomers even more eager to figure out what's going on with it. Another cool thing about 29P is that it doesn't ever get close enough to the Sun to grow a tail like other famous comets, such as the once-in-a-century comet, Tsuchinshan Atlas, which has recently made headlines. It passed the closest to Earth in 80,000 years. NASA's James Webb Space Telescope has been keeping an eye on 29P, helping solve some of the mysteries about the comet. And it has recently made another groundbreaking discovery. It has detected jets of CO2, good old carbon dioxide, coming from the comet. This was the first ever detection of CO2 jets on this particular comet. Webb has also discovered a jet of carbon monoxide coming from the comet. It can tell us a lot about the composition of the comet and its outbursts. What's especially interesting is that the jets seem to come from different parts of 29P's nucleus. Even though Webb can't actually figure out the nucleus itself because it's too small to see in detail, the jets coming from different locations on the comet's surface suggest that the nucleus may be made up of multiple objects. These objects might have different compositions, and it's possible that the nucleus is more of a composite body made up of smaller chunks that came together over time. Strangely, astronomers haven't detected any water vapor in the comet's atmosphere. That's unusual because the atmospheres of most comets often contain water. Our comet might lack water vapor due to the extremely cold temperatures on its surface. It could prevent water from evaporating or vaporizing. 29P isn't the only thing that Webb is studying. The telescope has also been making some big discoveries about galaxies far, far away. For example, Webb has recently spotted a galaxy with a pretty complicated name which appeared about 1 billion years after the Big Bang. What's super weird about this galaxy is that the gas in it is shining brighter than the stars, which is really rare. This could be a missing link phase in the evolution of galaxies, something that could help astronomers understand how galaxies transition from the very first stars, called population 3 stars, to the types of galaxies we see today. The stars in this galaxy are much hotter than we see in modern galaxies in local universe. Around 144,000 degrees Fahrenheit, compared to the typical 72,000 to 90,000 degree Fahrenheit of stars today. This could mean that the galaxy is in the middle of a super brief but intense phase of star formation, where huge, hot stars are popping up in a dense gas cloud. And this gas cloud is glowing so brightly because it's being hit with tons of light from these stars. The research team behind this discovery says that although the galaxy doesn't have population 3 stars, because the data shows it has too much chemical complexity, it still could be a guide for understanding how galaxies evolved, from the first stars to the galaxies we're familiar with today. There are still so many questions about this galaxy. Is it a rare phase, or is it something that happens often in the early stages of galaxy formation? Astronomers are hoping to study more galaxies like this one to figure it out.
The Hubble Space Telescope was put into a low Earth orbit in 1990. If you think about it, it's had over 30 years of experience looking at various space objects. It was named after astronomer Edwin Hubble and was built by NASA. It is also part of a group of devices called NASA's Great Observatories, along with the Compton Gamma Ray Observatory, the Chandra X-ray Observatory, and the Spitzer Space Telescope. The Hubble Space Telescope was built to explore the universe and answer some of its biggest questions, such as how galaxies form and evolve, and how the universe itself has changed over time. The telescope has made many important discoveries, including providing evidence of the existence of dark matter and helping to determine the rate of expansion of the universe. One of the most famous images taken by the Hubble Space Telescope is the Pillars of Creation. It's a photo of a region of the Eagle Nebula, where new stars are born. The photo, which was taken in 1995, shows massive pillars of gas and dust towering above the nebula. It has become one of the most iconic images of the universe. The Hubble Space Telescope continues to operate and make important scientific discoveries, despite some initial technical difficulties. In 1993, a problem with the telescope's main mirror was discovered, which affected its ability to focus light properly. A repair mission was sent to the telescope in 1994 to fix the problem, and since then, the telescope has continued to work perfectly. One of the more interesting discoveries made by this amazing telescope is actually pretty recent. A report based on the data from the Hubble Space Telescope shows that there is a faint glow in space around the solar system that cannot be explained by anything we know to exist. Because they have yet to figure out the source, astronomers call this mysterious glow ghost light. We don't know that this light is not coming from the stars or galaxies near the solar system, nor is it coming from dust on the solar system's plane. The researchers aren't sure what the source of the light is, but they think it might be tiny particles of dust and ice left by comets. But it's only a theory that has not yet been confirmed. When we study the universe, we often find bright things like planets, stars, and galaxies. But from time to time, we discover some light coming from places where we didn't expect to see it, like from between planets. This light may be coming from deep within our solar system, and it may be a new phenomenon that hasn't been studied before. In other words, there may be something at the center of our galaxy that produces a lot of light. Spacecraft Voyager 1 also captured images showing a lot of light coming from the edge of our solar system. How come we haven't noticed this until now? Well, because most of the light in pictures taken by the Hubble telescope comes from things close to Earth. But people usually ignore this light because they're interested in things like stars and galaxies that are farther away. We've never actually looked closely at the amount of light in the universe and where it comes from. Scientists have been using the Hubble to find faint galaxies that may have been missed before and which may be the source of this dim glow. They found that there are not enough such galaxies to account for extra light in the sky. It's not a lot of light, though. It's like the glow from 10 fireflies. But it doesn't make it less important. It shows that we may be missing something. Let's look at some other important discoveries we've made with the help of Hubble. Like dark matter, which we can't see but know is there because of its effect on gravity. It makes up for about 23% of the universe. By looking at how it affects light, the Hubble telescope helped make 3D maps of where dark matter is. These maps show that dark matter seems to be getting clumpier over time, which means it behaves very similarly to how gravity does. The Hubble telescope also discovered 2 new moons around Pluto, named Nix and Hydra, and studied the dwarf planet's changing surface. Additionally, it's found the mass of planet Eris, which is larger than Pluto. This helps scientists realize there may be similar objects in the Kuiper Belt, a region outside our solar system. This led to Pluto being reclassified as a dwarf planet. Further observations of these distant objects could help us understand the evolution of our solar system. Gamma-ray bursts are the most powerful explosions in the universe, and for a long time, no one knew where they had been coming from. Hubble helped us find out that these bursts happen in galaxies, producing a lot of stars and having few heavy elements. This suggests that gamma-ray bursts happen when big stars collapse into black holes. These galaxies have lots of big stars that fall apart quickly, and the stars there don't have much heavy stuff, so they can turn into black holes. In 1994, the Shoemaker-Levy 9 comet collided with Jupiter. Hubble captured the whole event in detail, like a resourceful journalist. The impact broke the comet into a lot of small pieces, which resulted in 21 other visible collisions. The largest impact created a fireball and a dark spot on Jupiter's surface. Hubble's observations not only sparked public interest in cosmic impacts, but also provided new insights into Jupiter's atmosphere. To move forward with our list of discoveries made by the Hubble telescope, we also need to talk about black holes. There are points in space where gravity has so much force that even light cannot escape it. The gravity becomes so strong that matter gets squeezed into a very small space. We know that this can happen when a star, like the Sun, nears the end of its life. At the beginning of its life, a star's hydrogen ignites in its dense hot core. Because of gravity, it tries to draw its own mass into a tiny point. As long as it has the energy generated by the hydrogen fusion, it also pushes outward. If we look at it this way, the life of a star depends on a delicate balance between these forces, and it can last millions or even billions of years. Once that energy is exhausted, the only force remaining is that of gravity. So, some stars become black holes. Since light itself cannot escape its pull, we can't visualize black holes. For the human eye, they are invisible. We need special tools and unique telescopes to help us point them out in the universe. Hubble found that most galaxies with a central bulge of stars likely have supermassive black holes. It also noticed a strong connection between the size of these black holes and their host galaxies, which might help us understand how the universe has changed over time. Then, what is a supermassive black hole, you might ask? Go ahead, ask it. It is a very large black hole that is typically found at the center of a galaxy. It is millions or even billions of times more massive than our Sun. These black holes are so powerful that they can swallow stars and even entire galaxies. Scientists are still exploring these mysterious objects, but they believe that they play a crucial role in the formation and evolution of galaxies. Now, before Hubble, we really didn't know how old the universe was. It often led to weird paradoxes, like the one where stars discovered by astronomers were older than the universe itself. But by figuring out the approximate rate at which the universe is expanding, Hubble helped us narrow down its age, which is about 13.75 billion years. Trying to figure out the exact age of the universe is an important question. That's because most astronomers think that the universe has not existed forever, but appeared in one really hot and dense fireball called the Big Bang. I wasn't around then.
In a galaxy far, far away, we found the most luminous object ever discovered, ASASSN 151H. Astronomers were left scratching their heads, wondering what kind of beast could produce such a mind-boggling amount of energy. But just when they thought they had this cosmic enigma all figured out, this object vanished into the depths of space, leaving behind nothing but a faint memory and a few bewildered astronomers. Fast forward to today. and it seems the universe has decided to play a cosmic prank on us. That's right, folks, ASASSN 151H is back, and now it's brighter than ever. So let's take a look at this impossibly bright space object. This event was first detected on June 14, 2015. We noticed it in the southern constellation Indus. It was located within a faint galaxy, which goes to show that sometimes the brightest things come from the most unexpected places. It's like finding a diamond in a pile of rocks, or a chocolate chip in a batch of oatmeal raisin cookies. No offense to oatmeal raisin lovers out there. ASASSN 151H was so luminous that if it were in our own galaxy, it would shine brighter than the full moon. Imagine that, no night, no stars. Just this mysterious thing lighting up the sky like a giant flashlight. Wouldn't that be cool? And kind of terrifying. But in all seriousness, it was a fascinating astronomical event. At its peak, it was 570 billion times brighter than our sun. That's so bright you'd be blinded by the sight of it even from afar. So picture this, it's 2015 and astronomers discover the brightest object ever observed. It was one crazy discovery because scientists had no idea what it could be. Is it a supernova? Is that TDE? What in the world is this thing? But then, as soon as they started to study this thing, it started to fade away. That was a huge bummer. Scientists could only sit with their theories and wonder what it could be. But then, against all odds, ASASSN 151H did the astronomical equivalent of a double take, and suddenly got brighter again. Astronomers were like, wait, what? Is that thing coming back from the underworld? For 40 days, its ultraviolet radiation charged up and increased 5-fold. Then it plateaued for a couple of months before finally dropping away again. And then astronomers were like, okay, that's just weird. So, what is this thing, and what caused its resurgence? Well, there are a few theories. First up, we have the superluminous supernova theory. A supernova is like a star's grand finale. When a star runs out of fuel, it reaches the end of its life, and then it undergoes a cataclysmic event, releasing a tremendous amount of energy and light. And this beautiful, crazily bright event is called supernova. It's like the ultimate mic drop, except the mic is the entire star. So, some astronomers think that this mysterious object might be a supernova, but a really, really big one. If once it was a star, it probably was 100 times more massive than the Sun. We've never seen such supernovae before, but maybe this star was gigantic and really loved attention. Next, we have the magnetar theory. So, during the supernova event, the core of the star collapses in on itself and forms a very dense object. Imagine a marshmallow the size of a mountain. Now, squeeze that marshmallow until it's about the size of an actual marshmallow. It's so dense that if you could somehow stand on the surface of a neutron star, which you can't because you'd be squashed by gravity, you'd weigh as much as 1 billion elephants. That's kind of what happens to a star after its fuel runs out. This super dense leftover core is called a neutron star. So you could say that a supernova is like a star's big send-off party, where it goes out in a blaze of glory, and a neutron star is what's left over after the party's over, like the empty pizza boxes and beer cans left after a wild night with friends. So, some scientists think that ASASN 151H might be something like that. They think that it was a star that ran out of fuel and became a neutron star. Then it spun so fast that it burst out super hot jets of material. It's like when you spray water out of a hose, but the water is really, really hot. These jets can heat up the stuff around them and make the supernova even brighter than usual. But our mysterious friend was even brighter than that, so this theory might be wrong. But that's okay, we still have a few others. Another theory says that it was caused by the collision of 2 neutron stars. Such a collision would cause a real grand spectacle, with clouds of glitter and all that stuff. Another cool idea is that ASASSN 151H might have been caused by a supermassive black hole tearing apart a star that got too close. It's like if a hungry monster grabbed a hold of a tasty treat, but instead of eating it, it just tore it to shreds and made a huge mess. This one's probably the coolest. And lastly, the most boring explanation. This theory suggests that this mysterious object might not be as bright as we think it is. Instead, its light is being magnified by a galaxy cluster or some other massive object in space. It's kind of like if you put on a pair of glasses that make everything look bigger and brighter. So, these were all the possible explanations of this event. And if these mysteries weren't enough, then remember that scientists have no idea why this object could start glowing again. They thought that maybe it ran into some nearby gas that made it a bit brighter. But then they checked if that was the case and didn't see anything. So, 2-0 in favor of the weird bright thing. In other words, ASASSN 151H remains a mystery. It's still keeping astronomers on their toes and saying, "You thought you knew everything about supernovae? Think again, puny humans." And this isn't the only mystery in our universe. There are tons of things that scientists still can't explain. For example, have you heard of dark matter? No, it's not a group of goth particles, but it's something even more mysterious. Dark matter is a substance that makes up about 27% of the entire universe. Yet, we can't see, touch, or taste it, even though it's hiding in plain sight. Scientists know that it's there because it has a gravitational pull on visible matter, kind of like how a good cheeseburger has a gravitational pull on me. The weirdest thing about dark matter is that we have no idea what it's made of. It's a mystery box, except we can't even see the box itself. And the mystery of dark matter still keeps scientists up at night. Another dark mystery is the elusive and enigmatic dark energy. It makes up about 68% of the universe, but we still have no idea what it is. Both of these are called dark because they don't interact with light or any other form of electromagnetic radiation. In other words, even though we know they exist, we can't see them directly. Can you imagine? We can only see about 5% of the universe. Who knows what else might be hiding there? One day, scientists noticed that the universe was expanding faster and faster over time. But it must be impossible, right? After the Big Bang, the expansion of our universe should gradually lose speed, like everything in nature. However, this wasn't the case. So something must be pushing it, right? And that's how scientists came up with dark energy. A mysterious force that's thought to be pushing the universe and making it accelerate over time. But what causes it? Scientists still have no idea. And until we figure out what all these things are, they will remain one of the greatest mysteries of our universe. So, our mysteriously bright object isn't even one of the biggest puzzles. We still have tons of things to explain. Who knows what other secrets the universe is hiding from us? Either way, let's hope that one day we'll learn more about our world and answer these questions.
Well, apparently Earth may not be the only place where you can have a glass of water. Scientists found one more world that looks very promising, because it might have liquid water on its surface. Even Mars can't compete with that. This planet is not too far from Earth and orbits a star called JG 887. Look, this is Earth and this is the Sun. Zooming out, see this speck of light? It's this star we're talking about. This star is 10.7 light-years away from ours. For comparison, Earth is way less than 1 light-year away from the Sun. And a spacecraft could get us to the Sun in a few years. But with our modern technologies, we would need over 270,000 years to get to that star system. And still, that's close, by space standards of course. Scientists call the planet a super-Earth because it's bigger than our planet, more than 6 times the mass of Earth. That's heavy enough to have strong gravity and a thick atmosphere. Another interesting thing is that, unlike many stars of its type, GJ 887 doesn't flare up much. Big stellar flares can blast away a planet's atmosphere. The fewer flares there are, the better chance a planet has of holding on to air, water, and maybe even life. When astronomers talk about the habitable zone around a star, they mean a spot that is not too hot and not too cold, where water could exist on the surface. But water isn't just about temperature. You also need air. Without an atmosphere, any water would evaporate or boil away instantly. According to researchers, the star's planet, JG887d, might actually have an atmosphere, which makes it a true habitable zone planet. Now, scientists already found 2 other planets around the same star back in 2020. But both were too close to the star, way too hot for liquid water to survive on their surfaces. The research also hinted at a 3rd planet around this star. But at first, scientists weren't completely sure it was real. They thought the data could have been a fluke or weird blips in the measurements. But after 5 more years of watching the star, the planet was confirmed. It orbits its star every 51 days or so you'd celebrate your birthday once every 51 days there. It's even shorter than a year on Mercury, which means the planet is very close to its star. Then why doesn't it burn up and could even host life? The thing is, the star, GJ887, is smaller and dimmer than our Sun. That's why it doesn't blast this 3rd planet with heat. So even with a shorter orbit, the planet's temperatures should be only a little warmer than those on Earth. Now, the good news is that the conditions on this new super-Earth might actually allow water to pool somewhere instead of evaporating immediately. No wonder this discovery is a big deal. For one thing, we might finally find life beyond Earth. Because where there's liquid water, there's a good chance of life. Plus, if we ever had to leave Earth, GJ887d could be a strong contender for our new planet. Now, one big problem for planets around small stars is flares. Many red dwarfs blast their planets with intense bursts of radiation, stripping away any atmosphere. Without air, water can't stick around, and life doesn't have any chance to survive. That's probably why Proxima b, the nearest planet outside our solar system, likely has no atmosphere at all. But GJ887 is unusually calm. It doesn't flare like other small stars. Of course, this might just be temporary, or it could last for billions of years. Either way, it makes GJ887d more promising for holding on to air. The planet is also heavy, which means a lot of gravity. It would make launching rockets tricky, and it wouldn't be an easy feat to go for a walk there. But heavier gravity is also good for keeping a thick atmosphere. If it developed on the planet, it could protect the surface and trap just enough heat. Unlike some planets, our guy doesn't pass in front of its star from our point of view. That means we can't easily measure its atmosphere by seeing how the starlight filters through it. Instead, astronomers need to use the radial velocity method, which detects tiny wobbles in the star caused by the planet's gravity. We still have a lot to learn about this world that might turn into a top travel destination one day. Every year, astronomers discover new planets outside our solar system. So far, we've found over 6,000 exoplanets, planets orbiting stars other than the Sun. What interests us the most are planets that could host life, or at least have the right conditions for it. The big goal is finding stable liquid water on the surface, not frozen solid or boiling away into space. For water to stay liquid, a planet can't be too far from its star. Too far and all the water will freeze into ice. Too close and it will boil off like water on a stove. And since every star is different, each one has its own habitable zone depending on its size, temperature, and brightness. So far, telescopes around the world have found about 70 planets in a habitable zone. But only 30 of them are rocky, like Earth, where oceans might actually exist. The thing is, only rocky planets can have oceans because they have a solid surface where water can collect. Plus, such planets also have gravity, which helps keep water in liquid form. Without it, water would quickly evaporate into space or free solid. Now, having these conditions doesn't mean life is guaranteed. Venus and Mars are technically in the Sun's habitable zone, but Venus is a roasting oven and Mars is a frozen desert. Life there seems unlikely. Or take this planet, for example. This super-Earth is 20 light-years away. Astronomers spotted it in January 2025 using telescopes at ESO in Chile. At first, it sounded very promising, but the planet's orbit is very stretched out, like a long oval. That means it swings in and out of the habitable zone during its year. When it's far from its star, freezing winter lasts forever, not exactly life-friendly. But even a perfect orbit isn't always enough. In the Gliese 667c system, 22 light-years away, astronomers found 3 planets in the habitable zone. But one, its planet F, is tidally locked. One side always faces the star and is scorching hot. The other side is in permanent shadow, freezing cold. Life could only survive in a thin strip between the two regions, or if strong winds spread heat across the planet. A true habitable planet also needs protection from cosmic rays, like a magnetic field and a thick atmosphere. Otherwise, radiation from the star will fry any chance of life. Take the TRAPPIST-1 system, discovered in 2016. 3 planets orbit in the habitable zone, but TRAPPIST-1b is tidally locked, gets blasted by stellar radiation, and has no atmosphere at all. The other 2 planets might have atmospheres, but we don't know yet if they can block out harmful radiation. Red dwarf stars, small, cool, dim, and also the most common in our galaxy, make things trickier. Their habitable zones are close to the star, so any planets there get hit by strong solar flares. Our closest potential second home, Proxima Centauri b, faces this problem. Unfortunately, it doesn't transit or cross its star from Earth's point of view, so we really can't study its atmosphere or see if it can protect life. And even planets that tick all the boxes, the perfect orbit, habitable zone, atmosphere, can still be nightmarish, like Venus. A circular orbit, habitable zone, thick atmosphere, and yet it's basically an oven with crushing pressure inside. Even Earth itself isn't perfect for life everywhere. The North and South poles are freezing. The Atacama Desert is almost completely dry, so life struggles there too. That's why astronomers aren't stopping at planets in the habitable zone. They're now hunting for signs of life in the air. Certain gases can hint at life. CO2 and methane might come from biology, or they might not. Some gases, like dimethyl sulfide, are thought to come only from living things, but scientists aren't 100% sure. So, the tricky part is, how can we tell if a gas is made by life or by rocks and chemistry alone? Well, we've got new telescopes, like ESO's Extremely Large Telescope. They can give us much more detail. They could help us find more planets in the temperate zone and even reveal certain traits that would tell us if a planet is truly habitable.
At first, it may seem like the sun is burning, but it's actually not true, because the burning of our star isn't chemical combustion, it's nuclear fusion. The sun can't run out of oxygen or stop burning because it doesn't use oxygen to burn. Regular carbon combustion requires oxygen. As soon as there's no oxygen, the process of burning stops. Now imagine a candle. If you cover it, it doesn't have access to oxygen anymore, and the process of burning stops. But in nuclear fusion, the nuclei of atoms are fused together to make new, bigger nuclei. Such changes cause atoms to become new elements. Nuclear fusion doesn't require oxygen or any other material altogether. You just need enough pressure or heat to squeeze the nuclei of atoms close enough for them to overcome their electrostatic repulsion and bond into one nucleus. In 2027, 2 teams of astronomers discovered a cloud of water floating in open space. It was the largest and farthest reservoir of water ever detected in the universe. It's a cloud of water vapor surrounding a huge black hole called a quasar, 12 billion light-years away from Earth. The environment around the quasar must be unique to somehow produce such giant masses of water. It was formed by energy waves colliding hydrogen and oxygen atoms together. The cloud contains 140 trillion times the entire volume of water on our planet. It could provide each person on our planet with a planet's worth of water 20,000 times over. Wow! Even cooler, astronomers believe this water cloud appeared just 1.6 billion years later than the universe itself. Scientists consider it another demonstration that water exists throughout the universe and was present already during its early days. At the same time, before this discovery, scientists had never found water vapor present so far back in the early universe. There is water in our home Milky Way galaxy, but most of it is frozen in ice. Not only water is floating out there in space, alcohol too. In 2009, scientists were examining a massive cloud of gas and dust in the center of our galaxy when they stumbled upon a surprise. There was ethyl formate within the cloud. This chemical is responsible for the sweet flavor of raspberries. They also found one more cool region. This one was brimming with ethyl alcohol, the same type found in many beverages. At the North Pole of Saturn, a mysterious storm is raging. It's ginormous, spanning an area larger than our planet and showcasing a beautiful but baffling hexagonal pattern. No one has understood yet why the storm has such a bizarre shape. After the hexagon was first discovered in 1987, it remained hidden in darkness up to the moment when sunlight exposed it again. Soon afterward, the Cassini spacecraft, designed to explore the Saturn system, provided a series of captivating images and even a video of the hexagonal storm. It turned out to be colossal in size. Its estimated depth is around 180 miles, and the eye of the storm is 50 times as large as the typical storm on Earth. The storm is also changing its color from blue to gold. Winds of hydrogen and ammonia surround the storm and move at more than 300 miles per hour. The storm has several centers. Some of them move clockwise, and others follow a counterclockwise direction. The largest vortex appears to be white, and it's twice larger than the standard hurricane on our planet. As for the hexagon itself, it's a jet stream made up of atmospheric gases. Experts refer to it as just a current of air and weather features. But there is one intriguing detail: a vortex sitting at a higher altitude than Saturn's clouds. It looks like a large towering structure. Saturn's auroras, triggered by the planet's magnetic field, are located atop of the hexagon, giving its appearance a mystical vibe. Astronomers have found a giant, likely active volcano near Mars's equator. It was literally hiding in plain sight. It's ancient and deeply eroded, but seems to be still functioning. There may even be remnants of a glacier ice near its base. That's why this discovery might indicate a promising new location to search for life, as well as a potential destination for future human and robotic exploration. The structure is still awaiting its official name. At the moment, it's referred to as the Noctis volcano. It reaches a height of 29,600 feet and spans an impressive 280 miles across. Such a giant size indicates that the volcano has been active for a very long time. In its southeastern part, there's a thin, recent volcanic deposit, and beneath, glacier ice might still be present. At a distance of 700 million light-years away from Earth, there's a gaping hole, a blank void with no galaxies, stars, planets, or asteroids, literally nothing. The void is a roughly spherical region about 330 million light-years across. Our home Milky Way galaxy could fit there billions of times over. That's the mysterious Bootes Void. It lies in the constellation of Bootes, the herdsman driving the plow around the North Pole. At first, this void had the name of the Great Nothing, but later it was given its current name. Now, we know that galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters, but between these clusters and threads, there are enormous empty voids that hardly contain any galaxies. Such voids actually make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light-years wide. The Bootes Void is one of the most massive ones, and has even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging together. There is a diamond planet out there that orbits a star in the constellation of Cancer, completing one full rotation in a mere 18 Earth hours. The planet's scientific name is 55 Cancri E. The radius of this faraway world is twice as large as Earth's, and its mass is 8 times greater. The planet is scorching hot, the temperatures on the day side reaching almost 5,000 degrees Fahrenheit. But the coolest thing about 55 Cancri E is that, according to some specialists, at least a third of the planet's mass could be diamond. That's the equivalent of around 3 masses of our home planet. Sounds like big money floating out there in space. How about we calculate how much this planet could be worth? Wait, someone has already done it, and the number is astronomical, pun intended, of course. It's 26.9 nonillion, and if you're confused by this number as I am, that's 26.9 followed by 30 zeros. Now, for comparison, one of the most expensive diamonds on Earth ever is the Cullion. It costs a whopping $2 billion, and its original weight was a mind-boggling 3,106.75 carats. It was, and still is, the largest raw gem diamond ever found. Later it was cut into many small diamonds. The largest of them is Cullion 1, which also goes by the name of Star of Africa. It has a carat weight of about 530, but imagine how much bigger and more expansive the Diamond Planet is. Nebulas are gigantic clouds of gas and dust, and some of them can have really unusual shapes, as if they were made this way on purpose. With time, gravity starts to pull these clumps of dust and gas together. They grow larger and larger, and their gravity gets more powerful. One day, this mass becomes so big that it collapses under its own gravity and forms new stars. Among some of the most beautiful nebulas out there, we must mention the Butterfly Nebula. Its wingspan is more than 3 light-years. And the structure inside the nebula is one of the most complicated ever observed. The central star, a white dwarf, is heated to an incredible 450,000 degrees Fahrenheit. It means it formed from a giant gargantuan star, likely more than 5 times the size of our Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. It's what probably makes the whole structure look like an hourglass or a butterfly. The Ring Nebula looks like a giant cloud of dust and gas surrounding an old, almost extinguished star. At first sight, it does look like a ring, but astronomers say the nebula isn't a bagel, it's a jelly-filled donut. They must be hungry. The deep space colorful object, more than 2,000 light-years away from Earth, is actually a ring that wraps around a blue ball-shaped structure. Each end of the structure sticks out of the ring's opposite sides. The pillars of creation look like something out of this world. See for yourself. They're located 7,000 light-years away from Earth in the Eagle Nebula. That's a young cluster of stars just 5.5 million years old. On a space scale, they're just babies. Once, the Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. and now you can see them with your own eyes. Those are the so-called pillars of creation, an active star-forming region. Look at this famous image. The blue colors represent oxygen, red is sulfur, and green means the presence of both hydrogen and nitrogen. The pillars are also bathed in the ultraviolet light coming from a nearby cluster of young stars. Unfortunately, the winds from those stars are slowly but steadily eroding the magnificent towers of gas and dust. Far out in space, a ghostly super-ancient galaxy is floating all alone. It shines with a faint glimmer of starlight and has hardly changed for billions of years. Astronomers have no idea why it's there or how it formed. Meet DGSATI, a living fossil galaxy. It's as big as the Milky Way, but is nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy so unique is that it's sitting all alone, unlike other galaxies of this kind, which are usually found in clusters. It might mean that DGSATI was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. Astronomers have discovered the most massive stellar black hole ever spotted in our home Milky Way galaxy. This newly found space monster is 33 times bigger than the Sun and sits 2,000 light-years away from us. Until recently, the largest stellar black hole found residing in our galaxy has been around 20 times as big as our star in terms of mass. As for the average stellar mass black hole, it's usually about 10 times as hefty as the Sun. Scientists spotted the giant black hole after a star started to wobble while orbiting in that area. The black hole got the name of Gaia BH3. The proximity of this space object to Earth makes it the second closest to our planet black hole ever discovered. The nearest one is called Gaia BH1. Makes sense? It's hanging out around 1,560 light-years away from us. This uncomfortably close neighbor has a mass of around 9.6 times that of the Sun. That means it's way smaller than the newly found black hole. Gaia BH3 is located in the Aquila constellation. From Earth, it seems to have the shape of an eagle. Interestingly, astronomers didn't expect to find a high-mass black hole lurking so relatively close to Earth and remaining undetected for so long. Now look at this marvelous exoplanet. It resembles a giant eyeball hanging out there in space. But it isn't the coolest thing about it. This distant world, identified in 2017, is one of the most promising places for finding life outside our solar system. The exoplanet is called LHS 1140b, and it shows signs of having a global ocean capped in ice. It's that very iris, a huge region around 2,500 miles across, which is constantly gazing at its host star. The planet has a radius of about 1.73 times the radius of Earth, and is 5.6 times as massive as our home planet. The giant eyeball planet orbits much more closely to its star than Earth does. It needs just around 25 days to complete an entire orbit. If the star were similar to our Sun, such a distance would definitely be too close for life to appear on the planet. But instead, it's a cool and dim red dwarf. That's why the exoplanet lies in the habitable zone of its star, where it's not so cold that all surface water would freeze, and not so close that this water would steam away. At the moment, LHS 1140b looks like the most promising candidate for hosting life in our planetary neighborhood. Solar flares are extremely powerful bursts of electromagnetic radiation that can last from minutes to hours. They occur when there's some magnetic disturbance in the Sun. Then, magnetic field lines in the atmosphere of our star get tangled and snap. This releases giant amounts of excess energy, including ultraviolet radiation and intense X-rays. These twisted lines appear in sunspots. Those are darker and cooler regions on the surface of the Sun. They form when magnetic fields that used to hide deep within our star rise up to the surface. As for coronal mass ejections, or CMEs, which are launched by solar flares, they're sent outward into space. They hit planets, satellites, and basically any objects in their path. Those that come across Earth trigger geomagnetic storms, which in most cases result not only in beautiful auroras, but also in power grid failures and satellite malfunctions. All these extreme solar phenomena, CMEs, sunspots, and solar flares, get much more intense during the peak of the Sun's 11-year-long activity cycle. It's known as solar maximum. Right before this event, the Sun steps up its activity. It starts to spit out giant blobs of fiery plasma, emits powerful streams of radiation, and grows planet-sized spots. At first, experts were sure that the current solar cycle would reach its peak in 2025. But judging by recent numerous sunspots, intense solar storms, and some other rare solar phenomena, solar maximum is likely to arrive sooner than that. This planet is as light as a piece of fluff stuck to your jacket. In the scientific world, its name is WASP 193b, but we'll call it the Cotton Candy Planet. It's located around 1,200 light-years from us. We'll never see it with our own eyes, but scientists say the Cotton Candy Planet is pretty much Jupiter's bigger, bouncier cousin. It has an extremely low density. Combined with other factors, like its high temperature and the infrared brightness of its host star, it makes it special. Interestingly, the planet's radius is just 1.46 times the radius of Jupiter, but its mass is a mere 0.139 times of our gas giant. May I have a close-up here, please? Thank you. See how fluffy it is? It would be absolutely impossible to stand on its surface should you ever reach this distant world. It's not often that you can meet something like WASP 193b at a planetary party. Such planets are rare. Their fluffiness might be caused by their planet stars. Those heat them, puffing them up like a marshmallow that's seen too much campfire action. The planet's super low density makes it a real anomaly among those 5,000 plus exoplanets we have already discovered.
You're traveling through space, trying to get through an especially rough patch. You gotta dodge asteroids, space debris, wandering black holes. Now, it's not an episode of a sci-fi series, at least not completely. For the first time ever, astronomers have found a black hole that's completely alone, drifting through space with no stars or planets nearby. This black hole is about 5,000 light-years away from us in our own Milky Way galaxy. Do we need to look for a hero with superpowers to save Earth? First things first, a black hole is a place in space where gravity pulls so much that nothing, not even light, can get out of this region. The gravity is so strong there because a huge amount of matter is squeezed into a tiny space. Supermassive black holes, hundreds of thousands to billions of times the mass of our Sun, are often found at the centers of galaxies. Most of them stay put or move at a very, very slow pace. But the newly discovered black hole is much weirder than anything we've seen before. First of all, it tries to avoid commitment. It's lonely, with no companion star or home galaxy. An even stranger thing is that it's zooming through space at a speed of 31 miles per second. What might be the reason for this speedy cosmic journey? Let's look at the following imaginary scenario. One day, a really massive star exploded in a supernova. It was the very star that formed our black hole. The resulting blast gave the new black hole a massive kick and sent it flying through the galaxy, starting its unbelievable voyage. Now, it's only one of a few possible explanations, but it sounds quite plausible. I bet you can't help but think, what if this wandering black hole decides to visit our solar system? Are we doomed? Scientists tell you to relax and breathe out. This black hole is very far away, and your chances of ever encountering it are infinitesimal, if any. Plus, this black hole is totally quiet and dark at the moment. One day, it might wake up and start glowing. It'll happen if it begins to eat something. In the near future, powerful new telescopes may find many more wandering black holes like this one. Usually, black holes are super hard to find because they don't give off any light. You can only detect them when they're eating nearby matter. That makes them glow brightly. Or when they have a companion star. In this case, it moves in a strange way, which gives away the presence of a black hole. But this newly discovered black hole is lonely, totally by itself. There's no glowing, no companion star moving hectically. So, how did scientists spot our cosmic wanderer? They used something called gravitational microlensing. That's when the black hole's gravity bends and magnifies the light from a star located behind it, kind of like using a magnifying glass, hence the name. This method allowed scientists to detect the black hole even though it was completely dark. All in all, black holes are fascinating things, and some of them are truly unique, like these biggest black holes ever found. You see, almost every galaxy has a supermassive black hole at its center. They're huge, with masses millions to billions of times bigger than our Sun. One of those is called TUN 618. It's a really huge and powerful black hole that's part of something called a quasar, a super bright spot in space emitting incredible amounts of energy. TUN 618 is very, very far away, about 18.2 billion light-years from Earth. And it's 40 billion times heavier than our Sun. There are also black holes that feed on their own kind. Black holes are known for devouring anything that gets too close. And this anything can include not only stars and gas, but also other black holes. Scientists witnessed a ginormous black hole at the heart of one galaxy being swallowed by an even larger black hole in another galaxy. It was the first time we detected such an event. The discovery was made using NASA's Chandra X-ray Observatory. One black hole weighs about 30 million times the mass of the Sun, while the other has at least 1 million times the mass of the Sun. Then, there is a bullet-shooting black hole. Apparently, black holes don't just swallow matter, they can also shoot it out. For example, astronomers studied one relatively small black hole, which is about 28,000 light-years from Earth and weighs between 5 to 10 times the mass of the Sun. And they saw how this black hole pulled matter off a companion star and then blasted some of it out in the form of huge bullets of gas. These bullets are super fast. They move at nearly a quarter the speed of light. Some black holes spin incredibly fast, twisting space around them at extreme speeds. One example is a black hole located in the constellation Agila, about 35,000 light-years from Earth. This black hole spins at a staggering speed of more than 950 times per second. If you could place an object on the edge of this black hole's event horizon, it would spin around the black hole at 333 million miles per hour. That's nearly half the speed of light. The smallest black hole discovered so far has been nicknamed the Unicorn. Located 1,500 light-years away from Earth, it's around 3 times the mass of our Sun. This makes it very close to the smallest possible size for a stable black hole. While black holes themselves are far away and difficult to study directly, scientists find new clever ways to study their properties right here on Earth. They've been able to recreate certain features of black holes in the lab. For example, black holes have a gravitational pull so strong that nothing, including light, can escape once it crosses the event horizon. To understand this better, researchers have created an artificial event horizon using fiber optics. They've also been able to simulate Hawking radiation, the kind that likely escapes black holes, by setting up experiments in the lab. These lab-created mini black holes help scientists understand the mysterious properties of real black holes. There are several types of black holes, and each of them is born in its own unique way. Primordial black holes are believed to have formed right after the Big Bang, when the universe was very young. Stellar black holes form when a massive star collapses in on itself. This causes a supernova, where the outer layers of the star explode into space and the core turns into a black hole. As for supermassive black holes, they're thought to have formed alongside the galaxies they're in. The size of the black hole is usually related to the size and mass of the galaxy. Despite what many believe, black holes don't roam the universe randomly, looking to swallow planets. They obey gravity like anything else in space. So, for a black hole to affect Earth, it would have to be very close, much closer than any black hole is to us right now. Even if a black hole the same mass as the Sun replaced our Sun, Earth wouldn't fall into it. The black hole would still have the same gravity as the Sun, and Earth would continue orbiting it just like it orbits the Sun today. It would get much colder though, so we wouldn't survive such a replacement in any case. But don't worry, our Sun will never turn into a black hole. It doesn't have enough mass to do so. Instead, in about 5 billion years, when the Sun reaches the end of its life, it will become a red giant star. After using up its fuel, it will shed its outer layers, creating a glowing ring of gas called a planetary nebula. What's left will be a cooling